Okay, we'll get started. Can I welcome you all to this joint meeting between the Royal Meteorological Society, Grantham Institute, Climate Change and the Environment and the Met Office. We're in for a very interesting afternoon, a range of speakers, panel session and obviously posters as well that we can look at during the tea break. We have a break at 4 p.m. Teas and coffees will be served back down the stairs and then just turn back on yourself. You'll see the table with teas and coffees at 4 p.m. And we also have a drinks reception at 6 p.m. So again, join us for that to have a look at the selection of posters we have downstairs. I'm Liz Bentley, Chief Executive at the Royal Met Society. I've just got a few admin things before I hand you over to Brian, who's our chair for the afternoon's meeting. And the first thing to say is that we're not expecting any fire drills this afternoon. So if we hear an alarm, it is for real and we have to leave the building. We leave the room. There are 3 exits. You can see the green signs. There are 2 at the back, at the top of the stairs, and 1 at the front. And we need to exit if you go out of the back entrance, back down the stairs, out of the main entrance of the building. And then there's a big tower. You can't miss it as you go out of the building. We congregate just to the left of the tower on the grass area. And if you go out of the bottom entrance, just turn left and it brings you right out to pretty much the toilets downstairs and then out the front entrance like everybody else. But as I say, if we hear an alarm, then we have to leave the building. We're not expecting any fire drills this afternoon. Can I just ask people to put phones on silent, please, so we don't get any interruptions? But I would encourage you to use social media as much as you like. If you wish to tweet about this meeting and share your experience this afternoon, then feel free to do so. We have a number of, obviously with Grantham and with the Met Office, so please feel free to use various hashtags. And we have an RMETS Meet hashtag as well, just to group all the tweets together. The meeting is being recorded and videoed and will be available on the website shortly after this meeting, as will all the PowerPoint presentations as well. You'll receive an email asking for feedback. There's a form, a survey that we ask you to fill in, so I would encourage you to fill that in. It will only take a few minutes. It really just helps us to understand what works about the meetings and what you'd like to see in the future. And then finally, just to mention that we're running a membership offer for delegates who are here today to join the Royal Met Society. It's a 50% offer for today. So if you're interested, there's a table just at the bottom of the stairs. Please ask one of my colleagues and they can help you with that. So without further ado, I'm going to hand over to Brian, who will chair and also present our first talk for the afternoon.
Well, thank you, Liz. And it's a pleasure for me to welcome you here as well to this meeting on the role for climate services in handling climate change risk and its contributions of UK CP18. So I'm taking my role as being an introductory one and not focusing on UK CP18 because everyone else will be. And so I'm due to talk for about 20 minutes. But then after that, we have 3 sessions of 20-minute presentations plus 5-minute questions. And then there's a session of 20 minutes before the break to actually open up the questions on a wider basis. So just taking my role then, I will try and sort of step back quite a lot from this. And looking back in my slides, I came a few from many years ago, and I thought I would actually start with those, just trying to present the thinking maybe back in the early 2000s. This is maybe a long time ago for some of you, but it's not too far back for me. And so I'm going to have 2 slides taken straight from a setback in there. And this was a time when I think we were moving away from those who dealt with weather and thought about 1 or 2 days. 2 days if you were lucky, probably 1 day. And those who thought about climate, and those who thought about climate, which was tended to be if you're talking about climate change, you might be doubling the amount of carbon dioxide and looking for your model to reach a different equilibrium than today's climate. And there was a move to actually then, by this time there's UK CIP 02 was on the agenda, starting to look at various decades in the future and how the climate might change. And people looking at weather were trying to extend their interest, looking how much forward they could go from 1 week even to 1 month. So the European Centre for Medium Range Weather Forecasting, looking up to 10 days, was started in 1979, and we're dealing with ensembles by the 80s. So a lot of people were tending to try and remove this barrier between weather and climate. And so we coined this phrase the seamless prediction problem, trying to move away from the past where there'd been Meteor 21 or somebody had done this, and Meteor 2 that had done this, to actually thinking about what the atmosphere did on all sorts of timescales. And we think about it then, the range of timescales and the range of phenomena that occur in the climate system, whether it's a blocking high, a single one, or maybe a month with recurrent blocking. If you don't understand the initials underneath, well, you won't learn them from me now. This isn't on, is it? Okay. Oh, yes, that's making... Right, I hope you heard everything I said before that anyway. So if you don't understand the initials, you won't learn them from me now, but they're phenomena occurring on different time scales, which give the possibility of predictive power and dominate those time scales. So there's, you probably recognize ENSO, the El Nino as well, being on the sort of seasonal to annual time scale. So there's a continuum in the atmosphere, and there's loads of phenomena occurring on those timescales. And we're thinking of climate as being much more the ensemble of the weather rather than a mean temperature. And getting back to the idea that the longer timescales provide the context in which the weather occurs, but equally the weather actually feeds back to change the longer timescale flow as well. So there's a feedback between the two, and thinking much more of an initial value problem rather than some sort of steady state problem with things put in there. And realizing that on the longer timescales, the impact is still going to be through the weather, usually. That's what's going to give the impact. Even though you may have moved the mean 2 degrees, it's going to be that really hot day or that really strong rainfall that gives the actual impact. And I won't get into the last one. Another one, I picked it up from a talk I had at the same time, and what we were thinking of as a future climate prediction system. So there's the modeling with its supercomputer, but on an equal basis there's the observations, whether these be for process studies to improve the models, to monitor the climate system, and the climate observing system as a whole to say what is going on. But underneath there, also understanding. The computer isn't everything. We actually have to understand what's there, know how to analyze it, diagnose, and think about the predictability problem, evaluate the models, etc. But the top one I did want to mention here, the users, and there was starting to be much more discussion of this interaction with the users, and realizing this must be a dialogue. Left on their own, the users will ask for everything you could possibly imagine, and the scientists will try and say, well, we can't do any of those, and we've got to meet somewhere in the middle where the user's being given products that the scientists think have a basis to them, and the users know the limitations of that product, but they are being presented with things that are useful to them. So a dialogue about them and what they mean. Now, as part of this development of thinking about the climate system and the climate services, then there was the World Climate Conference number 3 in 2009, and that then was developed or led to the development of the Global Framework for Climate Services, GFCS. And this was viewed as having components, a user interface, so very much that top bit I was talking about there, where data was being presented. The users were, but hopefully viewing this as an interactive thing, not where the product is just given and then taken away. And the Climate Services Information System, again, sort of somewhat related. Observations and monitoring, an important part of that, but then underneath that, the research, modeling, prediction going on, and importantly also the capacity development. And that's usually taken to be the developing world, but it could be also developing sectors in your own country, making sure the capacity is there to take on board the information that may be available to them. So the priority areas defined by that GCFS are perhaps what one would expect, the agriculture and food security, clearly very high profile now as well in terms of feeding the world's population. Disaster reduction, again, this was back in a few years ago, but still extremely important then, the disasters taking ever more people and money associated with them. Energy then feeding into the new energy systems, the development of those, and also the use of energy. And health, the realization that predictions on various timescales could be very important in dealing with health matters, whether it's actually eliminating the malaria, perhaps the idea that there could be a season where you could just eliminate malaria in some parts of the world. And then water, and the availability of water for human consumption, for agriculture, and also too much of the stuff which gets back to the disaster reduction. So this is considering all timescales, which is the focus of what I've given you up to now. And when you look at climate services, the more natural user, the one that finds it easier, in fact, is the one often on the shorter timescales. So in the UK, China Climate Science for Services partnership, which I'm partly associated with, then the major success story at the moment is really the Three Gorges Dam, where the 1 to 3 month forecast is found to be, from the Met Office, is found to be very useful in planning their water resources in that area. But what the subject today, though, is moving to the longer time scale of thinking about the next century or this century and decades in that century, and what will the changing climate be like. So now, from now on, I'm going to concentrate more on that UK CP18 area. And I thought first I'd show this picture from Ed Hawkins and Rowan Sutton back in 2008, trying to say, where does the uncertainty come from? In this case, you're thinking of decadal mean temperatures, but could there be other items? And if you can't read it, the lead time along the bottom is from 0 to 100 years. And then the colors show the fraction of the total variance, which is apportioned to those. Now, this is done using models, so it's not necessarily correct, but it gives a pretty good guidance. And globally, when you're past the middle of the century, then this is dominated by the scenario uncertainty, what greenhouse gases will we emit, but then certainly a major contribution from the uncertainty in models as well, going from one model to another, different answers. And the internal variability, the orange one there, the uncertainty associated with what happens in the climate system as it varies naturally is rather small beyond the 50-year timescale. But as you go to a more local region, that's still the whole British Isles, then you find you're getting a contribution from all of these. And if we think more locally within the British Isles, that will certainly be the case. So all three factors, internal variability, the weather, if you like, or the longer timescale fluctuations, the uncertainty associated with your model, and then what scenario, what are humans going to do? They're all important. And then, so how do we handle these then? So the internal variability then, what's been done over the years is say, well, in order to get a handle on this, we've got to run the same model lots and lots of times to get an idea of that variability from one run to another. So that means large ensembles of runs. Now, the model uncertainty, well, what is done then, or one approach to that is to use a range of models or different parameterizations in the same model, and also use observations to help you decide what's going on there. And then the last one, the human activity uncertainty, well, use a range of scenarios of that activity. But, I thought there was going to be something else coming. But all of those then are actually saying you need to do lots and lots of runs of models to actually handle this, whether it's the same model, different models, or a range of scenarios. A few words about the choice of the global model, and again, some of the tension there. So what do we do? Use the highest resolution model we can, because we know that does better with the weather. How much of do we make the physical parameterizations complex? And that might depend on how realistic we want the answers to be. But again, the more complexity, then the more detail there. And then what components of the Earth system do we want to be fully interactive in the model? For instance, do you want dynamic vegetation that as it heats up and dries up, the vegetation is going to die in the model? Do you want an active carbon cycle so you can give it the emissions of greenhouse gases and they'll be determined in the model? There's a tension between all these and with the need for many model runs, because each of them, if you go to the extreme, you're going to use more and more computer power on that one thing. So you want lots of model runs, someone else wants high resolution, someone wants best possible physical parameterizations, and then more components of the carbon system, whatever. So there's a real tension there in terms of the choice of the global model. And then how well do we want that model to work? I don't like the word validation, because that says we look at our model, we say, oh, it's something like observations, and then we put a tick. It's been validated. What we should be doing is really evaluating just how much does it fail, because they're all wrong. So it's just a question of how wrong they are. And so with what accuracy should it reproduce things such as the temperature in the end of the 20th century, the global temperature, or should it have a very good seasonal cycle? Should it model certain patterns of variability? All those things I mentioned before, blocking, the Madden-Julian oscillation, ENSO, NAO, the Pacific Decadal Oscillation, glacial cycles. Do you want it to model all those? Just how faithfully should it model them? Now, it's not going to be perfect, and then we should be asking ourselves, well, what do we do about the model imperfections? If our model can't handle blocking, should we be using it for discussing what the future of a European winter should look like, where the blocking is so important? So, or can we use it but then do something else to try and put that on? So again, it's something to think about there. Another aspect that's come in, say we have a global model at a certain scale, we can't make that too fine. So the idea of embedding a regional climate model in there, so a much higher resolution over your area of interest. And that's going to provide local detail and weather in your area of interest. But we do have the caveats that go to that. If there's something wrong with the global model, the regional model cannot correct it. So if it's a larger scale problem with the global model, it is a larger scale problem with your whole system. So the regional climate model cannot correct those large scale errors. They can provide detail, such as due to the orography or the partition between convective and non-convective rain. But if they depart too much from the larger scale model in which they're embedded, the whole system is not consistent. So you want your regional climate model to be giving you some new information, but if it's too new and different, then it's not consistent, so you'll have a problem. So I've said at the end, you should never be let the realism of the weather that comes out of a more detailed model get in the way of the fact of knowing the troubles that you have with a larger model and any errors in it. It's always been a concern of mine that as this is just what the impact community wanted, all this local detail, that the pressure and the finance for the larger scale modeling might disappear, because this is what the impacts people want. But this is not possible unless you get the improvements on the larger scale. So the whole system hangs together or it falls together. How do we use the data that comes out of our model for users? You could think of I'm giving a few examples here of how you could use it, and UKCP 18 comes into this. And one thing you could do is, number one here, is really rather simple thing where you could just say, well, the larger scale models of various sorts suggest the regional temperature. The temperature in our region might increase by 3 degrees. So we just take the weather of the past century and add 3 degrees on and give that as what might be a future climate. You could use all the model output you've got and combine it with your best understanding of the relevant physics to produce bounds on the sort of changes of something that might occur in future, whatever is important for that particular user. You could, number 3, then take the data from various models and model runs and add them all together to produce some probability distribution of variables of interest. Now, a big question here is how you add them together, because as soon as you do that, you are weighting each result you're given. So the question is what that weighting is that you're using. Now, what tends to happen with IPCC is no one wants to say this model is better than this one, so you give them all equal weight. Some of the models, so if you have 100 runs of one model and only 2 of another, and you weight them all equally, then it's going to look like the one model rather than the others. How should you use the observations in comparison with the observations to actually adjust how much you use them? That clearly depends what your metric is of how close they are to observations. Certainly what you get from this is not a predicted PDF for the future. It's a PDF in model world of the sort of things that may come out. Then the number 4 here is actually say, well, let's actually provide the data from what we think are some really good models and actually say, well, okay, this is a few realizations of the future from a model that we think is obeying the physics it should be obeying, and it works out pretty well, and see how your business or whatever is resilient to this actual weather that occurs in this model. So there's various ways you can handle this, and we'll see some of that in UKCP 18. Finally, I was just going to show this too, to think again about PDFs. This is actually for winter temperature at 850 hectopascals, and producing some probabilities for the 20th century and the continuous curve there from models, and that compares, that actually is all the IPCC models weighted equally. It compares somewhat reasonably with the observed PDF for temperature. This is for Midwest USA, actually, in winter. And then the one at the 21st century there. And you can see, well, there's a shift to the right. That says it's getting warmer. But actually, if you look a little bit more at that, you see the distribution is actually a bit narrower in future. And if you look at all the models, that sort of variance change, then some of them, a couple of them say the variance isn't going to change, but most of them say it will. And we think we can understand why the models are saying that. And if you look at actually the tail of the distribution on the cold side, you find that that tail is actually less extensive in the future than it was in the past. So the cold winters tend to be even less cold in the future. And that's something called the skewness of the distribution. And all the models are suggesting that will actually increase. So that's getting rid of that low tail there. Now that doesn't seem to agree with observations. Certainly if you listen to the media, all the cold winters that have been occurring to the USA. Now, I think those who look at the data say there actually hasn't been more variability in the USA in winter times, but that's where you start comparing with observations as well. How well does that actually work? So my concluding comments then really are just a summary of what some of the things I've said. Climate services are there for all time scales, but the focus today is on the 21st century and the decades in the 21st century. And some of the issues I've raised, the need for this two-way interaction with the users, a realistic assessment of what is required, what is possible, what can be used, what are the dangers of the product that's being given, handling uncertainty, the different ways that that's done, the choice of the global model, the sort of compromises that have to be made there, and just how do we evaluate model performance and what do we do say about it when the model does not perform too well, And of course, all models, as I say, will fail if you make your barrier small enough. And the embedded regional model, regional climate model, is not the answer to end all answers, that we can forget the rest. It provides more detail, but only in the context of the larger scale model. And then how do we use the model data for users in dealing with the risks in the future? And we have to take care of what PDFs actually mean and what the various aspects of those PDFs might mean. So that's my talk here, and the program does not allow any questions on my talk. So I think that's very suitable, because what I've been doing is trying to introduce what follows, and there are times for questions anyway, that 20 minutes at the end of the session. So I will end there, and I will lead seamlessly, which is the right thing for me to do now. I'm going to lead seamlessly on to Julia now. Julia King, or as she is known on the progress as Baroness Brown. So it's a great pleasure to welcome Julia here. I've had the pleasure of sharing various committees with her and always enjoyed that. It doesn't say that on her biography. It actually says she's an engineer with a career spanning senior engineering and leadership roles in industry and academia. She currently serves as chair of the Climate Change Committee's Adaptation Committee, subcommittee, I think, non-executive director of the Offshore Renewable Energy Catapult, and chair of the Carbon Trust. And I don't think I'll go on because it really is brilliant here. But anyway, we are very fortunate to have Julia with us today, and she's going to talk about what do policymakers need from climate projections. Julia.
Well, thank you very much, Brian. We have dropped the sub from adaptation subcommittee.
Okay.
The mitigation committee have agreed we're just as important as they are. So there's a step forward.
Okay.
I must admit, that was a really interesting presentation from Brian, and it kind of reminds me that I was reminded recently that back in 1890, Arrhenius was able to calculate that if we doubled the amount of CO2 in the atmosphere, we might get a temperature increase of about 5 degrees. One of the things that's impressive about that is that actually the conclusions today aren't so different, but what is hugely impressive is how we can now interpret that across so many different locations, and indeed starting to turn it into something that looks more like weather, which of course for those of us who are trying to use this data is enormously important. So I'm here representing the users. I think Brian has made it quite clear that we are the people for whom you have to make things really simple. So that's fine. I can live with that. So this is the Adaptation Committee. We have two roles, and I want to tell you a bit about what we do, because that's sort of key to how we use the outputs of things like UK CP18. We provide independent advice to the government, or to Parliament actually, on climate change risk assessment. So what are the risks to the UK from climate change? So we advise the government and Parliament on that. And then we report every other year on the government's policies to address its climate change risks. And that's this thing called the NAP, the National Adaptation Programme. That's for England, and that's a formal scrutiny role that we report to Parliament on. And we also do the same for the devolved administrations at their request. The Act only makes it clear that we have to do that for England. So we are very much, so in terms of the climate change risk assessment, we now also compile the evidence report, as well as recommending to the government what we think the top level risks from climate change to the UK are. So that big activity, the third round of that big activity, CCRA 3, is just kicking off at the moment, and that's where we'll be using a lot of the outputs from UK CP18. So this is the cycle of policy that we go through. At the top of the things the government does, and at the bottom of the things that we do as the Committee on Climate Change. At the moment, we have the second climate change risk assessment, which the government presented to Parliament in early 2017, and then in the summer of last year, in response to the top risks to the UK, they presented the second National Adaptation Programme. So we in the Adaptation Committee, in the middle of this year, will produce our first statutory report on the second National Adaptation Programme. But even more importantly, I think in many ways, at the moment what we're doing is we're preparing the evidence for the third UK climate change risk assessment. So this process is kicked off by that evidence report for the third climate change risk assessment, or for the evidence reports for the climate change risk assessments. Once we have a recommendation about what the risks are, the government puts its climate change risk assessment to Parliament, and it then presents its policy to address that, or its package of policies to address that, and then we start reviewing that on a 2-yearly basis. So that's the cycle that kind of goes around every 5 years. We're currently in the second cycle, and we're about to, we're doing the preparations for the third cycle. So that's the process which we as users of UK CP18 are doing. So what do we as the Adaptation Committee want policymakers to do? Well, unfortunately, unlike mitigation, adaptation is quite complex in terms of what do we measure. We haven't got one single parameter, the concentration of greenhouse gas in the atmosphere. So what we very much need government to do is to tell us what its vision of the world is in 2050, and then in some timescales closer to home than that. So is its vision that there should be no more people in homes affected by flooding in 2050 than there are today? Or is its vision that nobody should be in a home that is affected by flooding? Because it's quite important that we know the end point it's trying to achieve in order that we can monitor not only whether we're making progress in the right direction, but whether that progress is fast enough for us to get anywhere near that outcome. So we need really clear outcomes. And at the moment, we have some very nice outcomes, things like we'd like to leave the nature in a better state than when the government found it. But that's really hard for us to measure, so and to measure progress against. So we would really like very clear outcome-focused objectives. We'd like some points in time when they will have achieved particular things through their policy so that we can actually look at whether they're making progress. And clearly, because adaptation covers the natural world, it covers agriculture, it covers business and industry, it covers people in their homes, whether that's temperatures or flooding or whatever. We also need prioritization, because there's an enormous range of things a government could be looking at, but clearly it only has so much sort of bandwidth. So we really do need to be looking at the things that will have biggest impact. And monitoring and evaluation are absolutely critical. But of course, doing all of this requires this really sensible assessment of current and future risks. And of course, let's not forget there will be some opportunities as well, and we need to be flagging up those. And again, that's crucially what is essentially all based on the work that the Met Office kick off with their climate predictions. So for the third climate change risk assessment, CCRA3 evidence report, this is, if you like, the exam question. Based on the latest understanding of the climate risks, vulnerability and adaptation, what are the priorities for the next National Adaptation Programme, both for England and the devolved administrations? So that's what we've now got, big groups of scientists and consultants brought together to work on, and they're just kicking off at the moment. So it's built around 3 questions, the process we go through, and the very first input is the climate projections, which will include, as we kick off, it will include UK CP09, but also we'll be updating those to UK CP18 where that's relevant. So looking at what is the current and future level of risk or opportunity. I'll stick with risk for the moment. And if that's low, then we just come down to keep doing what we're doing now or keep watching. If that's high, medium, or unknown, then we need to assess whether that risk is going to be managed. Now, there will be some risks that aren't going to be managed because we can't afford to manage them, because actually maybe it's risks to loss of some coastline where actually we're just going to let nature take its course because we can't afford to build, and we wouldn't want to build walls around all of our coastline to stop them eroding or whatever. So there may be a very sensible decision that we're not trying to manage that risk, in which case we'll need to keep a watching brief in case our reasoning changes there. If there's a significant adaptation shortfall, then are there benefits to further action over the next 5 years, and indeed thinking about where we want to be in the longer term? And then we come down to, is more action needed here, or do we still need to define slightly better what action would be affected? So this is a research priority. So all of the areas we look at, so business and industry, society, people in their homes, work and productivity, the natural environment, farming and things, all of these go through this kind of analysis to produce the evidence report for the climate change risk assessment. And as you can see, we couldn't start doing that without the climate projections. So here are some examples of things we are doing. We have a research project for CCRA 3 going on, which is taking the UK CP18 sea level rise, incorporating and also new river flow projections, and being driven by the UK CP18 data to look at new flooding projections. We're doing new water projections based on UK CP18 rainfall data, again looking at changes in river flows, groundwater levels, and then we're very importantly looking at drought. And I'll say a bit more about drought because there's some interesting things there. One of the areas we're particularly concerned about, because we don't think it's looked at well enough yet, is the issue of interacting risks. So we're trying to look at feeding UK CP18 into systems models for different areas to look at how that drives interaction between sectors. We're very interested in whether we can find key thresholds for the natural environment so that we can look at adaptation pathways with particular thresholds as kind of stage gates, if you like, at which we may need to change or to reassess what we're doing. And of course we're we have a research project looking at behaviour change, which is particularly connected to what we do as humans, and of course how we behave in our homes, the impacts of high temperatures, whether we might be more prone to start wanting to put in flood resilience measures into our homes and things. So using projections again there to think about how people will behave and how we need to communicate to people in order to get them to take the most sensible adaptation actions. This is from the last evidence report for CCRA2, and it's one of the really beautiful illustrations of how important these projections are. So this is what the UK could look like in terms of water shortage in 2050, assuming we're on kind of roughly a 4-degree, it's called high climate scenario, which is somewhere around, let's assume, 4 degrees, reasonably high population growth. And the first picture, which is almost all red and orange, is where we're doing what we're doing now, but we're not taking any more action, any further steps to improve our reduction in water usage and our reduction in leakage and things. And we would end up with a country where all of the highly populated areas pretty much are suffering from very, very significant water shortages in the summer. However, this is an example where adaptation actions taken now could make a huge difference, that if we reduced household water consumption from 140 litres per head per day down to 92, and we have other countries in Europe where they already achieve that, so that's absolutely not out of this world idea. If we could address leakage rather more quickly, with some reasonable assumptions about what industry could be doing to reduce water efficiency, and we could actually give more water to the farmers and help them out in East Anglia, we could find ourselves in a position actually where we were pretty much no worse off than we are today. So hugely important to have that, the climate predictions, and when we model the adaptation actions we could do, we can say, well, here's a good outcome, and therefore these are the sorts of policy measures we want to see government taking. And I think that also emphasises how important it is that we have data at more and more local levels, because what the farmers in East Anglia need and how it's going to affect them is going to be quite different from what the situation in a forest in for example, somebody thinking of planting forests, new forests in Scotland. So this localisation of data that UK CP18 is going to bring is going to be hugely useful for this kind of assessment. Brian, I think, talked about uncertainty really, really well. I really liked his diagram. I always think we have to cope with uncertainty on these three axes. Brian brought it all onto one nice two-dimensional diagram, which made it much easier for me, actually, which is that we have uncertainty of which of the CO2 pathways will be going on. Are we heading more towards 4 or 5 degrees, or are we heading more towards 2, or are we going to be being good and hopefully getting more towards the 1.5? We have the spread in the modelling, and of course we have the weather variability. Explaining all of those to the people who need to use the data is of course quite complicated. Back in 2002, I think almost all policy decisions were just looked at an average result, which of course doesn't tell you, in terms of risk, is a very dangerous thing to do, actually, because you're looking at you're ignoring some really significant risks. I think by 2012, there was a lot of work done to make sure policymakers were aware of the uncertainty, but actually most decisions were still being made on the basis of average results. I think now we are very aware of the uncertainty. We do have some frameworks to handle them. I don't think it's being used anything like enough, and I would have said this is somewhere where I think the scientists and the Met Office with UK CP18 can really help with helping to think about how do we make sure that uncertainty is really being looked at properly. And indeed, things like the approaches through adaptation pathways, which enable us to set off in the right direction, but with potential points where we can accelerate or decelerate as things become clearer. Those sorts of approaches are very, very important, and we need to see much more use of them. So what do policymakers need? We need simple messages. That isn't because ministers aren't highly intelligent. That's because they are already quite stressed on bandwidth with having to deal with an enormous number of different things, and so they need to get a message that they can get very quickly. We need to be able to measure compliance, and that, again, the simpler the standards and regulations can be, the easier and more effective that is. Ideally, we need to be able to calculate costs and benefits, because that's hugely useful in getting the Treasury to fund things, and helping us boil uncertainty down to simple messages is something that we very much need help with. So what's going to be important for the next 10 years? Well, we need to know what the outcomes that the government is aiming for. What is the government saying to its citizens that it is going to deliver in terms of keeping everybody safe and well? And indeed, in terms of, we don't know whether the world is going to be on a 2-degree pathway, a 4-degree pathway, a 3-degree pathway, hopefully towards the lower end, but we don't know that. So we actually do need to know, are we aiming for the same outcomes in a 4-degree world or a 2-degree world? We may not be able to achieve them, but is that what we're going to be trying to aim for? So those are things we do need policymakers to tell us. We need to identify the best metrics. We may need still to develop some of them. And are there metrics which give us early indications of changes or tipping points ahead? Don't know, but that's something we're very keen to know. We need to communicate better with people and get people thinking about what they should be doing in their homes. You know, in the UK, who closes their curtains on a hot summer day? Something many of our continental colleagues would think to do, but none of us do, I don't think. I certainly don't, and then come back to a house and I think, gosh, it would have been a good idea if I had them. There's a lot we need, we need to get people prepared for this because their well-being is very much dependent on it. And we also still need to get the message across to people that it's not adaptation or mitigation, that if we do the mitigation, we don't have to bother with the adaptation. We do need people to understand that the changes are coming anyway, and even if we could stop all our greenhouse gas emissions tomorrow, the time lag in the impact means we still need to mitigate, need to adapt to quite a lot of this, and that's certainly something that I think that CP18 and the Met Office team can be a huge help with that communication. So thank you very much. Sorry to have rushed through that, and also sorry that I'm going to have to say to you, I'm going to literally need to rush off because I've got a European Union Select Committee meeting at 3:30 that I've got to get back to the House for. I've got, if you want a couple of minutes for questions, Brian,
Yeah, if we could.
I'm happy to take a couple.
Okay, if we could. So, thank you very much, Julia. Right, so do we have some questions for Julia before she rushes off to save the European Union or save us? I don't know which.
If only.
Yes, please. Go on. Yep, okay, we got one from Jason.
Hi. So UK CP18 concentrates on the longer timescales, so a few decades into the future. How much need do you think there is for new climate information on the seasonal out to 10-year timescale? And how would you feature that in the decision process?
Well, I think from our point of view, that would be enormously useful. And because government likes to do policy in kind of 5-year chunks or so. And so you need to know what are we needing to, you need to know both what do we need to be doing to be on a path to a world that will still be comfortable and habitable and productive in 2050, but also where do we need to get to in the next 5 to 10 years? And some of that is about, what will take such a long time that we need to start investing in it now anyway, but some of it is about things that can be done in shorter time periods. So you don't want to over-invest, particularly as we don't yet know whether we're going to be on that 1.5 degrees, hopefully, or 4 degrees, hopefully not, trajectory. So you want to invest enough, but not too much. And so knowing what kind of the priorities for the next 5 to 10 years would be hugely helpful.
How about the climate information itself? If someone could give you a 10-year forecast, would that be helpful?
10-year actual sort of weather forecast.
Yes.
I think it's those, for us, we almost can't work in that level of
that's what
detail.
I was wondering, yeah.
But it is those sort of the things about the temperatures locally and rainfall and those, how will those short periods of very intense rainfall that are going to cause overwhelming of drains and local flooding in cities and things, all of those kind of details and the localization of some of that would be enormously useful for this planning for the next 5 to 10 years.
Yes, well, we'll take. Oh, great. Let's bring you up now. All right, we'll take 2 more then. Yes, okay. If you can manage that before you go.
Hi. I wonder if, with the analytics that supports the CCRA work, to what extent that could be used by other departments, for example, particularly investment into critical infrastructure, for example, and its resilience going forward.
Well, really interesting, because I've just come here from a meeting with somebody from Macquarie, from the infrastructure investment people, and they are interested in exactly that. They were actually, interestingly, one of the things I've been hugely frustrated about with industry and companies, and talking to big FTSE 100 companies, and they're talking about what they're doing on mitigation, and you say, what are you doing on adaptation? and they say, oh, we insure against that. So that gets it off the board table instantly. The CFO comes in and says, oh yes, we've got insurance against that. You know, Zurich will cover that. But Zoom, we don't need to think about it. Macquarie are now thinking they do need to think about it. So and what they came to say was, so how do we find out about this and what should we be doing? So that's great. That's exactly, hopefully, what is starting to happen. And in my dreams, the insurance industry goes, no, we can't insure against this anymore. And suddenly, every CEO is going, what do we need to know? And they start really thinking about it, not just using pound notes to make it somebody else's problem.
As has happened in the rivers and flooding and for housing. Yes.
Yes.
Okay. Yeah. Right. We'll just have the one more then.
Thanks. So with the Paris Agreement, we've got a long-term goal of 2 degrees, which then the Climate Change Committee interprets nationally. You talked a lot about having long-term outcomes for adaptation. So I wondered whether you could give a few examples of what that could look like for the government and DEFRA to consider.
Well, I thought the water one was exactly that. It's one of the ones that the modelling that can be done and the information we've got enables us to do quite well, which is that, you know, it would be nice if the government would tell us that by 2050 it would like water availability for everybody to be just as good as it is at the moment, or they'd like it to be, you know, this much better. But if we assume we'd like it to be at least as good as it is at the moment, then actually we can produce models that say, even in a 4-degree world, inverted commas, sorry about that, shorthand, if we take sensible measures to reduce household water use, to deal with leakage in the water system, and to encourage industry to achieve not enormous but sensible water efficiencies, then actually we can still in this country have a good chance of having the same kind of water availability that we have now. And most of those are pretty much no regrets measures, actually. So there are things you should be making sure Ofwat is making the industry do. And we are indeed hearing the industry come up with 100 litres per person per day targets. As I say, we would like to see them just a bit tougher than that by mid-century, but other places in Europe achieve those levels already, so it's clearly quite feasible.
Okay, I think we better let you go now, Julia. Thank you very much. Do you have a microphone? Okay. Right, so we move on now to Jason Lowe. So let me tell you a little bit about Jason. So Professor Jason Lowe is a Principal Fellow and Head of Climate Services in the Met Office, Hadley Centre. He is also Chair of Interdisciplinary Climate Research in the Priestley Centre at the University of Leeds. And I'm aware he spent considerable time developing and communicating policy-relevant science, including a large investment in designing several of the Met Office Hadley Centre climate programmes. And so it goes on a little bit, but Avoid 1 and Avoid 2 are there as well. But in the interest of time, I'll just put over to you then, Jason, and you have 20 minutes to tell us about the new UK climate projections data. What is UK CP18? And there'll be 5 minutes questions at the end.
Okay, thank you, Brian. Is this one on? Can everyone hear me okay? I'll assume it is. So I'll be giving an overview, and then we've got 2 follow-on talks that will allow us to drill down into some of the detail over the land and the marine. Is that better?
Yes.
Yeah, that sounds a lot louder now. So, UK CP18, it was delivered in November last year, but the work leading up to it was many years in the making. It wasn't just the production cycle of running and analysing the models, it was that period of research before that took a great deal of time from a vast number of people in the Met Office Hadley Centre, but also the wider community. So we launched the first set of results at the end of November. There were 2 parts to the launch. So the first part was the high-level policy segment. Michael Gove gave an overview talk on the needs around policy. And then
several of us went downstairs into the basement for a stakeholder launch, where actually there are quite a few faces in the room today who also attended there. And the idea was to really engage with that community who will be able to use UK CP18. We've been collecting statistics since the launch. Now, statistics can tell a variety of stories, and what we're starting to do now is engage with users and understand how they're starting to use the product. But in terms of those registering on the website, so far there's a little over 1,100 users. A couple of people even registered on Christmas Day, which we thought was very impressive. Some of the users have specified what sectors they work in. That at the moment seems to be very dominated by the water sector. But you can see here there are also a number of users coming from sectors such as energy and agriculture as well. And it's that type of result that we want to drill down into further and see what actual decisions it's feeding into. We also had a lot of media coverage around the initial launch. And this was interesting to look at and compare back to UK CP09. On the whole, I think the media coverage was fairly balanced, although there are some headlines like rising fear that it's important to read behind. The Carbon Brief gave a very good overview, again, that I think achieved balance. And it was also good to see that the media picked up on messages that when people are thinking about resilience and making decisions, UK CP18 is one of the tools, one of the ingredients they can use. But it's not the only thing they need to know about their own vulnerability. They need to know about other risks, and they need to know about additional approaches that they can combine with the information. So this gives a smattering of some of the results that appeared in the newspaper. People picked up on temperature, they picked up on rainfall, but they also picked up on the sea level rise scenarios. So we'll make sure all of those are covered to some degree in today's description. When we started to think about UK CP18, we didn't just launch into it. There was a philosophy behind it. We wanted to understand what was a big ticket on it that made it different than UK CIP 02 or UK CP 2009. And we wanted to combine, firstly, the best new science. So we had access to more supercomputing, so that gave us opportunities, for instance, to look at either higher resolution models, more complex models, or greater ensembles. But the science had also moved on. The Met Office model was better at representing certain aspects of synoptic variability, especially over the European region. But we also had output from a more recent IPCC assessment. So we built those into the approach of UK CP18. The second part of the philosophy is involving users to a much greater extent. So we had two user groups, one focused on government users, one focused on a group that would include practitioners, consultancies, utility companies, academics. They provided very different types of input into the project, but they really helped, especially in shaping the delivery system and the guidance around that. And I think UK CP18 looks very different as a result of that user involvement. And the third part of the philosophy is a move away from this focus on either long-term averages or trends, and much more emphasis on the idea of future weather and capturing the variability around that. So what does it consist of, and what is the headline result? We call this the UK CP18 wheel. It's an infographic actually developed with the user group, and it tries to summarize what we have in UK CP18. So starting down at, 7 o'clock, we have the observations. The observations you will have seen for a number of years have been coming out from the Met Office in the form of the state of the UK climate. And what we've tried to do is align that with the model results that we're producing in UK CP18. We see this as a really important part. So users can use this to think about their present day risk, but we can also use this to look and see what the models are good at, what they're not so good at. If we go further around the wheel, there was an update of the probabilistic projections. So the probabilistic projections were introduced in 2009. What we did here was update them with inclusion of CMIP5 model information and also a range of improvements to the methodology. And this is the product that's most similar to what many users have had previously, and actually what we have seen downloaded from the website in the greatest numbers so far. Moving around, we have global projections. We have a set of these, 28 model versions, and these provide a type of storyline into the future. And that 28 consists of a set of models from the CMIP5, or the last IPCC assessment, and a set from the Met Office. And those two sets, although they do overlap, they sample different parts of the uncertainty space, and they provide a means of exploring storylines. And you can delve into any of those particular models and start to ask some of the questions Brian raised, like what is it good at in the present day? How does it compare with other models? Moving around, we also have a set of downscaled projections at 12-kilometer resolution, and later we'll be downscaling further to 2.2-kilometer resolution, so the sort of scale used in weather forecasting. The 2.2 will come out later this year. The derived projections, we express the results conditioned on 2 degrees or 4 degrees of global average warming as another way of presenting the results and another way of allowing people to compare different studies. So that's the product. The headline result is a greater chance of warmer, wetter winters, hotter, drier summers. If we look at temperature, we know there are a range of impacts associated with extremes of temperature. And UK CP18 shows that all areas are expected to experience warming. The warming is greater in the summer than the winter, and we understand why that is the case within the models. The amount of warming depends on the amount of emissions, and we put numbers on that, so we can tell the sort of stories around the balance between mitigation and adaptation, or at least part of those storylines. What I'm showing in the plots are the outputs from the 12-kilometer regional model results, and I'm showing 3 different variants of the model's change over the 21st century. And you can see a gradient from the south of the UK to the north of the UK. That appears actually quite robust across the models. You also see it in the global models, so it's a feature on both scales. In terms of the actual numbers, from the probabilistic results, we had 4 of the emission scenarios of the future. From the global and the regional model, we focused on the higher scenario. You can see that in terms of rates of change, that in the lowest scenario, the so-called RTB 2.6, then we're coming in with a median outcome of the order of 1 degree above the baseline, which is 1981 to 2000. But there's a spread going from 0 up to around 3. In the case of the higher scenario, the rate increases across the century, with the highest rate late in the century. And here there's a range going from around 2 to 7 degrees. We can also look at events such as summer 2018 and place that in context. So we know summer 2018 was amongst the warmest summers in the UK, along with years such as 1976, 2003, 2006. And we can see that in the baseline period, using the results of UK CP18, that had a very low probability. Even by present day, that had increased to above a 10% chance. By 2050, here you start to see the scenario dependence, whether you follow high or low emissions. And both are coming in around the 50 to 60% number. But the chance of exceeding the summer 2018 temperature by the end of the century, you can see a very big difference between the two emission scenarios. What we're hoping to do, and have started to do, is compare the near present day and the present day with other techniques so we can understand the robustness of this further. If we move on to UK precipitation, we know that precipitation, either too much of it or too little of it, leads to impacts in the form of drought, in the form of flooding. When we look at the CCRA, certainly the second and the first report, we see amongst the threats these associated with precipitation being very high on the list. So a lot of users amongst the initial set of downloads have really focused and asked questions around the precipitation aspects. When we look in the range of products, well, we see in winter we expect precipitation to increase quite significantly. And we see that across the probabilistic products, but also in the global and the regional model simulations. In the summer, we expect precipitation to decrease, but when it does rain, we expect the summer storms to typically be more intense. And this is something that'll be really interesting to investigate when we have the 2.2 kilometre results, because there, rather than parameterising convection, we're starting to actively represent it explicitly. The plot on the right, here the black lines are observations, but we've overlaid results from the model on top of that. In this case, it's from the 28 global model simulations with the blue and the orange representing the two sets from CMIT-5 and the Hadley Centre model. And you can see the wintertime increase in precipitation. You can see more of those events where there's been an increase in rainfall, but you can also see that we do still get dry winters. So they're not going away. We're shifting the balance of numbers between the present and the future. In terms of the numbers involved, again, we'll show the time series coming from the probabilistic part of the assessment. And we can see in the winter case this increase, which in the median is going up to somewhere between about 25 and 30%. But again, we can see a range that goes actually from a slight reduction in rainfall to some very large increases as we look across that distribution. I think James will probably say more about these simulations over land in the next talk. Over summer, you can see this opposite trend, the decrease that we've talked about. You can see the numbers on that. And if you look at the extreme end of the distribution, we've actually got a small increase, but the majority of the distribution is showing this decrease that in some cases is exceeding 70% in these simulations by the end of the century. The other aspect I wanted to touch on is sea level rise. Matt will drill down into this, but we know again from looking at many past reports of events like the 1953 storm surge flood that eventually led to the development and introduction of the Thames Barrier in the 1980s, or more recent events along the coastline. I've picked one here from the news, that sea level rise is a serious potential threat. So providing updated information on this, and this is an area where the science is moving very quickly, is one of the key ingredients of UKCP18. So we find that sea level rise will occur for all of the emission scenarios we looked at, even the lowest scenario. And it continues throughout the 21st century and beyond. In many cases, it's not the time average that is of most interest. It's the change in sea level extremes. But we find that the change in the extremes appears to be mostly driven by the change in time mean. So we're effectively lifting the extremes onto a higher baseline. And our central, or our best estimate, is similar to UK CP09, but with a different set of models producing the estimates of storminess, that the surge component won't change. Although when we go down this result of saying, well, let's look at individual models, we can't rule out that change. So those who are particularly risk averse need to factor that into their thinking too. This item of the science moving quickly, I think manifests in particular around thinking of the contribution of the large ice sheets to sea level rise. And one of the things that we included with UK CP18 was a sensitivity study looking at a range of alternative published estimates of future land ice melt and a contribution to sea level rise, and discussion around where those scientific uncertainties are. We also, for the first time, looked beyond 2100. So we had users, for instance, from the nuclear sector, asking us, well, we want to go beyond 2100. Actually, other users have started to ask that as well, given the lifetime of infrastructure. So we've produced numbers beyond 2100, but I consider these to have a lower confidence. So they give an indication, based on our physical understanding, of the direction of travel, which is still going up, even in the lowest scenario. But using them in that way, I think, is important when it comes to the decision making. There are also changes in tidal characteristics and waves around the UK. The precise change, it's very dependent on location in those cases. And again, Matt may want to say something about that. These are some of the numbers involved. You can see, if you look from London up to Edinburgh in this case, that the amount of sea level rise is geographically varying. One of the big influences on this is the pattern of vertical land movement, which is making larger the sea level rise around the southeast and slightly smaller in the case of Edinburgh. And what we're showing here is the lower RCP 2.6 scenario in blue and the 8.5 in the orange colour. For London, the range is extending from around 30 up to 115 centimetres. So these are really quite large numbers by 2100. I'll go to this. The obvious question is, where do I find the information? So there are three ways we worked out with users of accessing the information. So one is go to the website. So on the website you can find pre-prepared material, you can find the high-level messages, you can find the reports describing the science, and you can find some guidance that talks about how people have used the data, but also talks about some of the pitfalls of misusing the data. There's a user interface that lets you go in and tailor the results, so you can select appropriate regions or periods for the variables of interest and look at maps or plumes. That's a product that is probably most used so far. You can also go in and look at the raw model output. So we wanted to be as transparent as possible on this. So you can go to the CEDA data catalogue and download that. We're finding the research community is, at the moment, dividing itself between the CEDA data catalogue and the user interface. So we have this item now. I will reiterate the point I made early on, that this is one of the ingredients into thinking about future planning, along with things like physical lines of evidence and along with an understanding of vulnerability. But nevertheless, we think it adds to the evidence base in a useful way. So thank you very much.
Thank you, Jason. Thank you, Jason. I'm not discouraging questions now, but there will be an opportunity after the land and marine ones to ask Jason more. But is there anyone who has a burning question at this point? Otherwise, I think I will, Jason, with due respect, just say move on to that, and then we can have you back later for that.
Yeah, it probably makes more sense
Yeah,
to be
that's
quite
what I
honest when
thought,
we've
yeah.
had the next two.
Yeah. Okay, so we do move on to two now. We're going to really get down to what does the UK CP18 say about land and marine projections. And we've got James Murphy and Matt Palmer. James is going to be leading us on the land and Matt on the ocean. So I'll read out a few words of Biblio now, and then I won't interrupt them again on that, as they hand seamlessly from one to the other, I'm sure. Okay, so James, as it says, has spent his Met Office career developing and evaluating climate model projections on various timescales. Initially, it was the dynamical extended range forecasting to a month ahead, but in the recent years, the past 15 years, he's moved to this sort of UK CP line and been involved very much in the development of UK climate scenarios and national climate change risk assessments. And Matt, who is to come, is the lead scientist for sea level research at the Met Office Hadley Centre. His work is focused on understanding the ocean's role in the climate system and developing global and regional sea level projections. And he's going to be involved in the IPCC, the IR6. So I'll leave it over to them now. Over to
Thank
you.
you very much, Brian. So I'm going to speak for 10 minutes and then hand over to Matt for the rest of the slot. So please give me a shout when my 10 minutes is nearing. I want to make sure that I do that. So I'm going to talk about the land projections. So Jason's already given you a fair bit of information about the land projections. So some of the messages you'll see on that will be, similar to the results he's shown. So I'll try and kind of fill in some more of the details and give you some sense of the strengths and limitations, I think, as well.
You need to be on full screen, I think.
Oh,
Yes, that will do it. That will do it.
that one.
No, up and slightly to the, no, just there, that one. Yep.
Yes, right, thank you. Yes, okay, so we have these three strands in UK CP18. So one thing we can say that we've expanded the range of information available to users, but in terms of the challenge of making their lives simpler, I'm not sure we've succeeded yet, so apologies for that. So strand one is an update to the probabilistic results that we first provided in UK CP09. And these are conditional PDFs provided for several different future emission scenarios. But then in strand two, we have a new set of global climate model projections, 28 of them, provided only for the RCP 8.5 scenario, although we have used statistical methods to provide also sort of estimated results relevant to a stronger mitigation scenario or a strong mitigation scenario 2.6, and also specific global warming levels. And then strand three is sort of the regional downscaling strand, and currently that consists of 12 projections run at the 12-kilometre scale, also for RCP 8.5, driven by some of the strand two global runs. And as Jason said, coming later, there is also a further set of 12 projections at an unprecedented resolution of 2.2 kilometres using a convective permitting regional model. And that's coming later this year. So just to dig a little bit more into those various strands, so the probabilistic projections are derived from a much larger set of model runs than any of the other strands. So we put about 350 climate model simulations into these. They are provided for the four main RCP scenarios and also for the old SRES A1B scenario, and that's for backwards compatibility with UK CP09. So users can compare the new against the old results. And another key development is that whereas in UK CP09 they were presented for 30-year average changes in climate, we're actually now presenting at the annual timescale, so that you now see the effects of variability on 1 to 30-year timescales. And that's illustrated in the plot on the right there. So we see an example of precipitation change for Scotland in winter, where the blue curve shows the spread of possible results for 20-year averages centered on 2070, whereas the red curve shows a spread of individual seasonal projections specifically for the year 2070. And you can see the wider spread, which reflects the effects of annual to decadal variability, thereby giving more ability to assess the changing risks of those seasonal events, as Jason was explaining. And then the other plot on the left is just one example to emphasize the fact that we are seeing, provided these spreads of results for the different emission scenarios, and you see the difference in this case in global temperature between RCP 2.6 and 8.5, which the differences start to emerge several decades into the future. So in terms of some strengths and limitations, so naturally I'd like to start with some strengths. That probably affects my role in providing or organising the provision of some of these things. So in the case of the PDFs, I think the main strength, or the main purpose, if you like, is that they are intended to be the major source of information on uncertainties. So that's why we use, for example, 350 model simulations to build these rather than 10 or 20. And there are some developments since UK-CP 09. So we build these by combining one of these ensembles where we perturb parameterizations in a single model, in this case an older version of one of the Hadley Centre models, and then we include a multi-model component to capture some of the structural modelling uncertainties. And we've updated that aspect to include CMIP5 results, the latest multi-model generation which informed the last IPCC. And we also go through this exercise that Brian mentioned in his talk, where we try and constrain some of these results by applying a set of observational metrics as some key aspects of past performance to see if we can weight up the particular projections that we believe more strongly according to some set of those. And we have expanded the range of those to try and refine the way we do that to some extent. And the plot here shows one example where we actually predict, one of the variables we actually predict is CO2 concentration itself, because in this case these are emissions-driven projections where we plug in the emissions and then try to account for the uncertainties in carbon cycle as well as physical climate processes. So the green curve shows if you just have what you get if you just have an unconstrained range of possible CO2 pathways in the case of RCP 8.5, and the grey curve shows what happens if you apply this constraint due to historical CO2, which tends to rule out the higher CO2 levels and therefore the higher temperature levels. But in terms of limitations, I think the key one to really emphasize that these are not PDFs of everything. And there's been a lot of discussion about this in the community over the last 10 years, and we can absolutely agree that it's important to emphasize that these are conditional. In this case, on the set of climate model simulations that went into them, which are quite large, but still limited by the knowledge and capabilities within those models, and also by various assumptions in the statistical methodology that we use to combine all the information. Also, they're only available for a limited set of variables, so they don't have the full flexibility that basic climate model would have, and they lack full spatial coherence. So you can use them to look at uncertainty ranges at particular points that you might be interested in, such as in the map that I've shown there, but you can't use them, for example, to look at things like simultaneous risks from a nationwide drought affecting different places in the country at once, or in the effects of variables we don't have, like a 7-day heat wave or something like that. So the global projections, in some senses, were built to kind of address some of the things that the PDFs can't do. So in this case, there was a lot of new work to take one of the very latest Met Office Hadley Centre, or UK coupled ocean atmosphere model that's going into CMIP6, and we took a very closely related version of that to build a new perturbed parameter ensemble, sampling some process uncertainties in that framework. These were developed very much using the seamless modelling principles that Brian mentioned, where we use both weather forecasts and climate model simulations to try and find good sets of parameter combinations to use in these simulations. They're also run by global modelling standards at relatively high resolution. And as Jason said, they're augmented importantly by a set of alternative CMIP5 models to add diversity in the set of future pathways of climate that these simulations provide. So in terms of strengths, one strength we think comes from the flexibility of providing basic raw climate model output. So you can look at a wider range of variables and impacts than you can from the PDFs. And you can also importantly look at what drives the regional changes that you might be interested in. So how do large-scale patterns of global warming remote to the UK lead to changes in circulation that then might affect an impact like flooding or heat waves or droughts. And they are, of course, fully spatially coherent. And we have tried to place quite a big emphasis in developing these simulations on achieving improvements in at least some aspects of the dynamics of regional climate variability, given these sorts of uses. So the example here is one of the storm track, where on the top we have observations from a set of ECMWF reanalyses for 1981 to 2000, The bottom panel shows the average of these 15 new simulations. It's not a perfect simulation, but by the standards of previous modelling, we think it's not too bad in certainly capturing the major aspects and maxima of the storm track. However, it's very important to recognise that despite all this use of the latest model and this high resolution, there are some important limitations in these runs as well. One is that they don't do what the PDFs do, so they're not a data set to use for counting up, for example, the chance of exceeding a certain level of temperature or rainfall response. They're not designed, partly because there aren't enough simulations to answer that sort of question. But also, although they perform in general, when you look across a wide set of variables quite well, they do contain some notable biases. So we haven't suddenly fixed the perfect model problem. So for example, there's a notable cold bias in Northern European winter temperatures that users would need to be aware of. And we also found when we run the historical part of these simulations that between about 1950 and present, although we end up at a level of warming since the start of the 20th century that is quite similar to observations, if you compare the orange and black curves there, you can see that from 1950 the simulations follow a very different pathway to the observations. So they cooled rather too much between 1950 to 1980 and then warmed too much afterwards. And we think some of that may be due to the fact that they have a rather strong aerosol forcing. So users would need to think about how that might affect their projections in the near-term future, for example. And then the regional projections, they are 12 versions of these new global simulations configured for a European domain, run at 12 kilometers. And the main purpose of these is in many ways very similar to the global projections, but to provide output for more detailed regional assessments. So here's where the good side of the downscaling paradigm that Brian was talking about comes in. So for example, the plot there shows one example of a potential case study where we picked out the heaviest local precipitation event during 1981 to 2000. And the picture on the right comes from the global driving simulation, and then the regional model on the left replicates the large-scale synoptic situation for this particular day, but then it interprets the two frontal systems that we found on that day in a much sharper and more realistic way. So that's the good side of regional downscaling, some of the added value that it can bring. But of course, the limitations, and here I'd very much echo what Brian said, is that while the high resolution may add some skillful detail, it also inherits biases from the driving simulation. So that winter cold bias, for example, that you see is still present in the regional model and is not fixed somehow by the use of higher resolution. And also, very importantly, in contrast to the other strands, regional projections don't have a multi-model counterpart to the perturbed parameter simulations, so they don't sample as wide an uncertainty range in some variables. So here's an example for summer rainfall, where the range that you get from the 12 high-resolution regional simulations on the right explore various levels of summer drying, whereas if you take the global simulations from strand 2, the dry end is similar to the regional models, but the wet end actually benefits from the inclusion of CMIP5 models and shows the possibility of an increase, which the regional models don't have. So in the last couple of slides, one thing I would encourage users to think about is how we might use the simulations and projections together to kind of derive strength from the various strands of information. So here's just one example plotting changes for England and Scotland in summer temperature and summer precipitation for 2061 to 2080 relative to 1981 to 2000. The probabilistic results are shown as the box and whiskers, and they tend to give projections which are either as wide or wider than the other strands. And then the global projections are shown in the orange and blue, and where the CMIP5 models are in blue and the Hadley Center simulations are in orange. And what you see is that when you combine the two sets, you can get ranges of response out, which are often quite similar to the PDFs. But the CMIP5 models are really crucial there to add diversity, whereas the Hadley Center simulations all tend to show a rather strong warming, which populate the upper end of the PDF. So this is how users can use these probabilistic results as context to inform the more detailed studies that they might do with the global and regional simulations from the other strands. And it's important also, I think, to think about this in a multivariate context as well, because a lot of impacts don't just depend on temperature or rainfall, but both. So the plot on the right is an example of how this plays out if you look at a joint distribution of temperature and rainfall changes. So I think Jason's already summarised the main results, so I won't dwell on those, and I'll just leave that up there and hand over to Matt.
Is this on? Oh yeah, great. Okay, thanks to the meeting organisers for giving me the chance to talk to you today. I'm going to talk about the UK CP18 marine projections. So I guess what I'll do is I'll try and give you a flavour of the work we did and the key results, and on the final slide I'll sort of talk about some of the strengths and sort of limitations in a similar way to the way that James has just with the land strands. Okay, so the basic elements of the marine projections, really there were sort of two main groups. The emphasis was very much on the 21st century projections, so we considered changes in mean sea level change, so that's just the average water level around the UK coast going up over time. We looked at the changes in the drivers of extreme water levels, storm surges, and the wave climate, and we also had a look at the potential for changes in tides. One of the novel aspects, and perhaps the strength of UK CP18, was this taking a look beyond the 2100 time horizon. That's particularly important for sea level because we know we have a lot of committed sea level rise on multi-century timescales, and so I'll show some results for that as well. Okay, so I'm going to start off with telling you what I think are the sort of take-home messages from this presentation. So the most important thing to take away is that UK coastal flood risk is expected to increase substantially over the 21st century, and this will be the case under all climate change scenarios. Mean sea level rise is the dominant factor, but the amount of mean sea level rise we see will vary both by geographic location and by climate change scenario. In terms of drivers of sea level extremes, we find surge and wave changes of up to about 10% of the mean sea level signal, but we can't rule out larger changes in this. And one of the limitations here is the fact that we have limited model ensembles to work with, and you know, so we have to be a bit cautious about what the messaging around that. Coastal sea level variability is an important consideration for shorter term planning. So this resonates with what Brian was showing in his first talk. We find that on multi-decadal timescales, the sea level variability is an important consideration. And really, the overriding uncertainty, I would say, the most important major sort of uncertainty is to do with the future ice loss from Antarctica. This is a very active field of research, and I'll talk a bit about this at the end of the talk. Okay, so we've already seen a picture like this in Jason's talk, so I'm not going to dwell on this. I think it's interesting to note the dependence on the low or high emission scenario, and what we also see is this contrast between cities which are in the north and cities which are in the south that seem to suffer more sea level rise than those in the north. And so one of the things I thought it might be useful to talk about a bit is why do we see this spatial variation in the amount of sea level rise? One of the reasons is to do with this process called glacial isostatic adjustment. So this is the solid Earth response to the end of the last ice age, and as a result, the ice that was lost over the north is promoting an uplift of the solid Earth, and that gives us a negative contribution to sea level change, so that the Earth is rising, and conversely, towards the south, the solid Earth is sinking, and obviously that exacerbates the sea level rise that would otherwise happen. There is a second process as well to do with the spatial fingerprint of change associated with Greenland. This is to do with the effect of Earth's gravity. So the mass of Greenland ice actually attracts the water towards Greenland. As that mass is lost, there's less gravitational attraction. So actually, what we end up with is a sea level fall for that particular component of sea level rise, but a rise in the south. So it's this spatial fingerprint that is also giving rise to a gradient across the UK. When we look at the UK average sea level here, this is to give you a flavour of the sensitivity to the climate change scenario. So this is the low scenario and the high scenario. And this is what it looks like sort of spatially. So this is just re-emphasising that same pattern that we saw before. We can see that if we compare projections to local tide gauge records, one, that they seem to agree well with the rates of change, but we can also see that the tide gauges reveal this fairly strong year-to-year sort of variability, and we need to take this variability into account when we're doing our coastal planning. Okay, so this is some work that's in preparation at the moment, and just to talk you through this quickly. So going from left to right, we are taking a clockwise tour of the UK around these various tide gauge locations. The green shaded areas are showing us what the mean sea level change is, and then on successive panels, we have an estimate of what the changes in waves and surge and tide might be. And the key thing to take away from this is that we can see that the influence of waves and surge and tide are all much less than the mean sea level change itself under this scenario. So it's really the mean sea level that we have to think about primarily, but we shouldn't rule out substantial changes. And it's very difficult for us to talk about what the spatial characteristics of these changes might be in future, but we can be a bit more confident about the likely magnitude, which we think will be about 10%, or could be up to about 10% of the mean sea level signal. So another sort of interesting aspect of UK CP18 was the tide work. So as a result of the time mean sea level change, you can end up with changes in tidal characteristics. So that's another thing for decision makers and coastal planners to think about. I'm going to quickly sort of talk briefly about the exploratory projections. So now what I've done is I've extended the time horizon to 2300. These are, as Jason commented, these are really to provide a first view of what might happen. These are much longer time horizons. Clearly the assumptions about the emissions scenarios and things become much more illustrative on these sorts of time horizons. But what we can see is that that sea level continues to rise under even the lowest scenarios. So sea level rise for the UK and indeed elsewhere is very much an adaptation problem as well as a mitigation problem. And that sort of resonates with some of the messages from our second speaker. When you get to these large sea level rises of several meters, then we really should expect to see some substantial changes in tidal characteristics, at least at some locations. I don't know if this is still working. Can you hear me still? Should I try this? I'm almost done, actually. Is this on? Okay. Okay, great. Okay. So I think, so the key uncertainty is really to do with Antarctica. And so I'm just pointing you to a very recent review paper that's published in Nature. The key thing here is there's been a new mechanism proposed for rapid ice loss from Antarctica and large levels of sea level rise. So this is the sea level equivalent of 2100. But this is a controversial sort of mechanism, and we're still trying to understand whether this might happen in reality. And so really, a lot of future research is likely to be directed into understanding whether this could happen in real life, and indeed making observations of Antarctica to detect whether such changes are underway. I'm going to finish, I guess, with the key findings again. I guess I should briefly say what the strength of UK CP18 is. So one of the nice things about this set of projections is they're all based on the CMIP5 models. It's a consistent set. We are really moving forward from the AR5, so the last IPCC assessment in terms of the methods that we're employing. So they're very rigorously peer-reviewed methods. One of the limitations really with the surge and wave changes, I would say, it is the small ensemble sizes that we had available to work with. And I'll just leave you with the sort of report authors and some of the acknowledgements. There's a huge number of people involved. So thanks for your attention, and I'll take any questions.
perhaps I can ask Jason and where are you? Yeah. So I think all three, if we have all three now, and then we can put all the Q&A into one now. So actually it might be worth joining us also if you want to sit down there. I think mine's still working there. Right. So we have Matt, James and Jason here. So really it's now up to the question time for the whole of UKCP 18 and what is being produced for the users. So after tea we get to how it's being used or will be used, but now it's questions on UKCP 18 itself. So would anyone like to open up? Yes.
Thank you for your presentation.
Yeah, I can hear you anyway.
The question I wanted to ask is the success for UKCP 18 depends on the user community. So I was going to ask what communication plan have you got in place to sort of connect to the user community? I know you said there are 2 user groups, but the key thing is translating some of the science for user community. And are there those industries that you started to make use of projections?
Shall I take that one? Is this one on?
Yes.
So yeah, you're quite right. So the measure of success is if it's used, if it features in a large number of studies, for instance, that feed into the next climate change risk assessment, and if we see people starting to plan adaptation around it. So there are some things we've done so far. One, we've tried to design the delivery system so that it caters for things that users have asked for, that it includes metrics that users have asked for. That goes part way. What we're also doing, for instance, we have a team led by Phi Fung, who is somewhere up there, putting his hand up at the moment. And the purpose of that team is to really help users exploit UKCP 18. So some of the things in practice that means, one, events like this one and events that perhaps go a little bit further than this, that sit down with users and explore particular examples and talk through what that might mean. Demonstration studies, and we've done some of those already, but going further with those, I think, provide examples of good practice. And also the design of training material. So one of the big things is putting together a series of online training as to how people might access and better use UKCP 18. But we're very keen to also hear ideas back from the user community. So we've got some things in place, but we want to hear from users too.
Okay. Ron.
So one cross-cutting concern for risk assessments is low likelihood, high impact scenarios of one sort or another, or the potential for surprises, to use more colloquial language. So you mentioned uncertainty around the Antarctic ice sheet as one such scenario, but of course there are others, and one particular possibility, which of course has been known about some time, is significant changes in ocean or indeed atmosphere circulation, but in particular changes in the Atlantic Ocean overturning circulation, which could of course impact sea level rise around the UK as well as weather patterns and so forth. So was thought given to that kind of scenario, and is there particular information provided about the potential for surprises?
So I can probably make a start on that, then others can pick up. So I think it's fair to say we don't have sort of specific material in UKCP 18 itself at the moment about climate surprises. So as you know, there was a chapter in the last AR5 report, and some of this was also reflected in the CCRA2 actually, which I worked on. So we did try and provide more sort of qualitative advice, reviewing the wider literature around, you know, the current understanding of the risks of a complete AMOC collapse, for example, or missing processes in the model like the methane cycle, or interactive ice sheets and things like this. So, I think it's fair to say that UKCP on its own, we didn't design it to be a one-stop shop for the sort of totality of that wider context that users might want to consider. It is kind of designed to be a climate model-based product, and it's fair to say that the new simulations, some of them do actually have a rather weak meridian overturning circulation in the present day and do get down to rather low values in the future. But that's not necessarily the same as a scenario of a model which would start at a reasonable level and completely collapse. So I think there is scope for the development of some of this wider qualitative advice, surveying some of the theoretical insight that's in the literature, for example, whether CCRA3 might provide another opportunity to do this. So Jason or Matt, I don't know if you want to.
So Rowan, as you know, this is a topic that interests me as well. So last time around, we developed a High++ for sea level rise that went beyond the model simulations and brought in other strands of evidence. We haven't taken that to conclusion in this UKCP, but what we're doing with the academic community is updating the High++ now actually to draw on UKCP as one strand of evidence, but bringing other aspects like paleo, like model sensitivity studies. Now go beyond sea level. CCRA2 commissioned a piece of work that looked at high-end scenarios in other variables. I was involved in that. And we tried to apply and develop similar methodologies. I think there is a need to do that again for the future, to take account of what we've learned since the period before AR5 and CCRA2. And I think it does make use of going beyond the scenario simulations that we see in UKCP18 with targeted experiments. Are you thinking of something in particular?
Yes, Rowan, come up. No.
Just to be very brief, because I'm sure others have got questions. First, of course, potential surprises is significantly broader than just H++.
It is, yeah.
And I suppose if I could paraphrase your response, James, and maybe this is an important point for users to understand, is so the phrase you used was that it's a model-based product, which I appreciate it is, but and of course the PDFs in particular will tend to be relatively smooth. I think you'd probably agree in terms of how they're constructed. But there is a knowledge base out there that implies that in fact, if you could sketch, and I wouldn't attempt to quantify, the totality of knowledge, then in fact the potential possibilities for future climate could be more multimodal than is implied by this particular model-based product. Is that fair?
Yes, I think it is. I think it is. I mean, as you say, the PDFs reflect the model simulations that went in to produce them, and they don't really include, they don't include scenarios of rapid collapse, on say, the decadal timescale of the AMOC. So inevitably, the PDFs don't reflect that. And even if you did, even if they did, the nature of the processing, as you say, would find that sort of cliff edge event difficult to pick up, I think, in a probabilistic sense. So it is important that we communicate that wider knowledge somehow.
That's the key point.
Yes, over there, yes.
Some questions about the surge. So I guess the fact that you're not getting much of a signal in the surge is due to the fact that you haven't got much of a driving signal in the maximum wind speed. But the surge is also a function of bathymetry, exact bathymetry of where you are, the translation speed of the storm, the size of the storm. So the underlying driver of this, the atmospheric model that's used to drive this, has that been validated against actual surge observations?
Yeah, so I didn't really feel I had time to get into a mode evaluation in this presentation, but we did have a look at the ability. So there's the surge model itself. It's a bit. I have to unpack the question a little bit. There's the surge model itself, which is the operational surge model, which is very very well validated, and we're using the same bathymetry. Then we're forcing that with climate model data, which has been downscaled by Eurocordex. So there has been some, and actually those climate model simulations do a pretty good job of reproducing the surge extremes, which is the way that we assess them. I think one of the questions for the surge in general is, No, we don't find a big climate change signal in any of the simulations that we've had access to, and we searched pretty hard to try and find the models with the biggest sort of responses. But we're a bit limited on the forcing data sets. That's one issue, which is limited our ensemble size. I think there is another question as well about, at this stage, we can't really necessarily robustly attribute the changes we see to the climate change signal either. So we're not really sure whether these are low frequency variability in these simulations or whether they're a true climate change response. So that's another area of research we're trying to understand better, is what's the potential for low frequency variability. Is that helpful? I don't know if I've really answered your question, but...
So just to confirm, so basically the storms that you do have are not very much stronger. So if they were much stronger, then presumably you'd see the signal in the surge.
Okay, so I think that we need to better understand as a community what the relationships is between traditional metrics of storminess and storm surge. So I think that it's not a given necessarily that a stronger storm gives a stronger surge. I think what is key is how that storm tracks and whether that sort of maintains phase with that storm surge and helps it build over time. I think that's, and I don't know that there's been that much work looking in that sort of detail, but it's one of the other strands of work we have going forward is to try and understand better what leads to these strong surges, and that's another reason to look in a long control simulation, which is what we have plans to do, to try and better understand which conditions are leading to the largest surge events. And it's one thing that we can't get that good a handle on just from the historical record, because there just aren't that many of these events to look at. But it's a great question.
Jason or James, would you like to comment on possible changes in storminess? What signals do we have there?
Yeah, so we've looked at the global projections in particular, and we do see, we've looked at sort of weather types. So these are daily weather types which tend to reflect in particular the positive and negative phases of the North Atlantic Oscillation. And you do see some signals in those, but they tend to be different between the two different components of the strand 2. So I'm trying to remember which way around it happens at. But I think in the new Hadley Centre model simulations, we tend to get an increase, I think, in the positive phase of the NAO, a shift towards the loading on that. But it's not really backed up in the CMIC5 simulations. So again, I think that's where it's really an illustration of how we can use those simulations to show possible changes, but to consider the totality of the information to avoid potentially overconfident interpretation that you might find if you just took the Hadley Centre model results on their own.
So it's another case where we have a bimodal thing, really, if you put it together rather than a single distribution.
That's right, yeah.
So again, as you said, this has to be taken account of when someone's looking at this. Yes, okay. Yep.
So, there seems to be general consensus that Britain is moving towards a more Mediterranean climate, warmer, wetter winters, hotter, drier summers, and that means the distribution of rainfall throughout the year can become significantly different, and the summer rains may be, it was said, come in very large occasional dollops. That surely means that we do need to have a look at the methods by which water is stored. Because I do remember on one or two occasions where we had long drought periods in the summer, then we got heavy rain. The message was, it's the wrong sort of rain.
I think this will be a topic at least one speaker will address in the session after tea. So, great question, but I think we'll leave that to after tea. Okay, so again, yes, right, so there's two down here, so, yep.
In the context of climate services, I guess I wonder whether you could provide a bit of an overview of how users can assess current risk, because I know you have other products associated with this, and I think it'd be very useful for many of the users to understand how they can assess current risk and their vulnerabilities.
So with the UK CP18 products, they can use any of the land strands. So for instance, one thing that I showed was the type of temperature event from 2018. And the results we plotted there came from looking at the probability distributions. In that case, what we're sampling is both the uncertainty in the model, but also the internal variability, so two of Brian's uncertainties. So that gives us one aspect, and I have a rather interesting curve that overplots that on the observations, and you can see the degree of overlap. Now we can also look at that using the global model projections, and that's very similar to an approach that's used by the event attribution community. You do find quite a significant overlap between the two methods when looking at the summer temperature, actually, from an early look at that. You can do the same with the regional model, but with the regional model, because it's only driven by part of the global model ensemble, that driven by the Hadley Centre model. It's interesting in the present day, before there's been a significant trend, less so when you start to look further into the future. But I think the other part of this is UK CP18 provides part of the tool set. So, for instance, there are other approaches like the unseen method, and the unseen method, there we're using the hindcast simulations from initialized forecasts to create alternative historic worlds. The number of years we have available from that is letting us delve further into the tails. Again, though, the results are conditioned on the observations. So for me, a really big gap at the moment is comparing the unseen with event attribution and with what comes out of the probabilistic approach.
Yes.
There was mention earlier of a peer review process over the work. I wonder to what extent that can provide metadata context about robustness and transparency of the product. I don't know if you could say a little bit more about that.
We went through, I was chair of that process, yes, so, and we're still talking to one another. So, but it was a very critical, sort of positively critical process, I think, which was, I hope was a benefit to the product, and I think it was good all-round scientific discussion. I think mainly what's happened is that our discussion led to some modifications of what has been produced. And so the discussion that we had is actually all there on the data, on the web. So you can see the things that we were probing, such as the warming in this model, which was at the upper range of the climate sensitivity, and just how confident were they? Did they have reasons to think that this was credible, and general discussions around that. So that's certainly one example where I think what we had before shows you the process we've gone through. I think what you get in the results tends to be the outcome of our discussions rather than, so you're not seeing what we commented on initially, you're seeing what we agreed on in the end. So I don't think you can look on ours as we're putting a stamp saying this is reliable and this isn't. But I think you may want to look at our discussions to see what we probed as being perhaps something that needs to be looked at further. And then you can see the responses to that. So it's a sort of timeline on our discussions, which I hope you'll find useful. I don't really want
I mean, we found it a very positive process, and I think what we ended up with was better as a result of it. I think where it made the biggest obvious differences are one around this idea of how do we bring in other models to deal with particular features that show up, for instance, in the Hadley Centre model. The other was around making more use of the 12-kilometre regional model and gaining, I think, a much greater understanding of that before moving on to the 2.2. And I think the process we went through to look at that in more detail was really quite useful. And I think the third one was around, when it comes to guidance, to making sure that we were picking up caveats around biases, around making sure that we don't assume all decisions can be made purely with UK CP18. And I think the fingerprints of that are all the way through the science reports and guidance reports.
So you see from the sort of thing I gave at the beginning that we were coming with you, how well do you do on this? You must tell everyone the good and the bad of this product so that they can really judge it properly. This is not an exercise of saying everything's wonderful. This is what the best we can produce at this moment. It has these pluses and these minuses. So,
interestingly, when we looked at the feedback before we started to shape UK CP18, one of the requirements that came up from the user surveys was putting more focus on what the models are bad at as well as what they're good at. So that wasn't a surprise, but it helped us achieve it in a sensible way.
I should say that review, we had 11 people on the committee, and half of the committee was essentially UK, half overseas, and it was a really high-level committee, so we gave them quite a grilling, I assure you. I think with that, we'll actually say thank you very much to these three. Tell us about UK CP18. It moves to the user community more afterwards, but now we have tea, and we also have 5 demonstration projects with posters, so I hope you'll look at those as well. So we're meant to be back here at 4:25, so we'll certainly start by 4:30 anyway, okay? Thank you. Thank you. Sorry, I couldn't see who I couldn't see who it was. I was waving at you. You were over there, whoever you were. Right. And combining discussions as we go.
Yes, yeah, no, absolutely.
Oh yes. They need to go back into this.
I think there's a little
Yes,
thing here.
they go into this.
Yeah.
Yeah, mine's not the blink now.
Yeah. Don't know how long it takes to charge up. But
Oh, yeah. Yes, I should try and make sure they go back in there.
yeah, yeah. Otherwise, we've got electric mic, I guess, and one of the handheld, which is what Matt used, I guess.
Yeah.
And yeah, they are very good.
Yes, yes,
Yes, good, yeah. I'm just going to copy, there was one talk that came quite late, Jason Lowe's. I just want to copy that onto our memory stick. I'm not quite sure which is our memory stick. So.
There is a memory stick.
Just put one in, yeah.
Okay,
and I don't know that there's different ones. So, I don't think that's it. So does he know. So we,
So I assume those will be working. And you have 3 panels, don't you?
Yeah, I've got 4 panels.
4 panels. Oh, okay. And these are working with you. Well, one of them didn't seem to charge up, so I've just taken it off and tried the other one.
Yeah. So one, I don't know which one it is actually, but one was working at all.
Oh, that looks better.
Yeah.
How did you get that out of it?
Just pressing that button down for a little while.
Oh.
It beeps in a minute.
No, maybe that one hasn't been in anyway. So this, so those two.
Brian, are there any slides for this at all? I'm just wondering. I'll probably turn this off actually. Or
Yeah, I think it'd be good to get that. Right, I'd like to welcome you all back from Steve and from General Projects, and we now have a panel session for the next 50 minutes or so, and it was scheduled chaired by Dr. Fiona Harrison. Fiona is currently Deputy Director for Climate Adaptation, thank you. Deputy Director, oh my goodness, for Climate Adaptation and Forestry Policy at DEFRA. And she's worked in a number of science-related posts across Whitehall. But I hadn't realised her life before this. So before joining the civil service, she was part of the senior management team at an internet startup. And then before that, well, she has a DPhil in quantum theory from St Andrews. DEFRA is known as a hotbed of quantum theory. So, and she did a postdoc on that for some years at the University of Auckland, focused on foundations of quantum theorem, theoretical understanding of new experimental work in quantum measurement. Anyway, she's under a new guise today. Fiona, over to you.
Thank you very much.
Sorry.
Take their seats. So welcome to this session. As Brian said, I'm a Deputy Director in DEFRA responsible for climate adaptation. So I and my climate team are responsible for the sort of governmental air of the boxes in Julia's slide, ensuring that every 5 years we lay in front of Parliament a UK climate change risk assessment. So before tea, we heard a lot about what the projections actually are and how they're feeding into the climate change risk assessment. And what we're going to be looking at now is the sort of much wider picture of how we actually build resilience and what place the projections play alongside a lot of other really important bodies of knowledge and approaches, some of which have been touched upon already, things like understanding other changes, demographic or land use changes, other pressures, understanding vulnerabilities better, being able to cope with uncertainty. Doesn't matter how good your models are, the future is always uncertain. We need to understand how we can make the best decisions in the face of that. Also thinking about what our desired outcome is, what success might look like, what we want to achieve, and drawing on understandings of risk and risk perception and how we actually get people to behave differently. So I'm delighted to say that I've got a very distinguished panel here who know lots more about all those things than I do. I'll just very briefly introduce Suraj Desai, who is Professor of Climate Change at Leeds University, Climate Adaptation, and has just been appointed one of the UK's climate resilience champions as part of the UKRI and NERC strategic programme on climate resilience. Liz Parks from the Environment Agency, so very wide experience in actually delivering and improving resilience in a practical way. Nick Pigeon, who is Professor of Environmental Risk at Cardiff and head of the Understanding Risk unit there, and that's correct, isn't it? Yes, and Jason Lowe, who's from the Met Office, but also has a chair in interdisciplinary climate science at Leeds. So I'm very grateful to all the panel members. And just to kick off the discussion, I'm going to ask, with the exception of Jason, who's already had a chance to talk about his approach and what he's sort of putting on the table in terms of how we build resilience. I'm just going to ask the other three panel members to say a couple of minutes about what they see as the important other things that we need to be taking into account, building into an interdisciplinary approach.
Okay. Great. Thanks very much. Fiona, can you hear me at the back? So I'll just make a couple of remarks, I guess, about some of the challenges of making progress on particularly using this type of climate information in a climate service context, particularly in the context of adapting to a changing climate. And I guess I'll start off with a slide that Brian showed when he was talking about the global framework for climate services. You had quite a raft of different areas. So health, disaster risk reduction, agriculture. So we need to recognize that there are many different actors, organizations that are sensitive to climate variability and change. And so the context where they operate is incredibly important in how they are going to tackle risks and also climate risks. So they've developed this over the years, centuries sometimes, decades, and so on. And obviously, with the advent of climate change, they've had to change many of their routines, or some of them are changing. So the context really where I guess climate information fits is that it needs to be able to be incorporated in many decision routines, many different institutional contexts, all the way from water managers, and we'll hear from water manager in the next session, all the way to biodiversity conservation, farmers, and they're looking at this across timescales. So again, Brian had a nice slide on the seamless nature of this problem. So some of them are looking for things for tomorrow, the next season, the next year, all the way to the middle of the century and so on. So I think the final point I want to make, to be brief, because you want me to be brief, is that I guess this is the beginning of a journey a little bit in this climate services context. You now have 3 strands, for example, to the land projections. Some of this needs tailoring to particular contexts of different decision makers and different organizations. So you could talk about it as bespoke services. And this will require more research to get to for example, decision relevant variables, crop yields, water availability, and so on and so forth. So I think that I'll probably finish there and say tailoring is going to be very important as a challenge.
Thank you very much.
Thanks, Fiona. Can you hear me at the back okay? Thank you. So, unlike most of the people in this room, I'm not a great scientist, I'm not a scientist at all. I was reflecting earlier that I'm a human geographer, so I'm absolutely passionate about the interaction between man or people in the environment and the impact it has on us. And something Jason was taking us back to the launch of the projections actually at the Science Museum, and something that struck me on that day, and I remarked upon, is there's a lovely quote at the Science Museum about that science helps us to better understand what goes on in our world and to make better decisions. And for me, that's the bit that's crucial. It's the decisions that we need to make out of all this. I think we are blessed with some of the very greatest scientific thinking in this country, probably in this room. The thing that is going to transform this is how we use this to make decisions. So the bit that constantly feels like it's lacking to me is the engagement part of this. I probably understood 3/4 of one of the slides that went up today, and that's my own, I don't come at this with a great climate science background. So for me, the bit we have absolutely got to get right is that engagement with the decision makers, that understanding who they are and what is it that they need in order to make the decisions that they need to make that are robust for the future, whether that is about driving carbon out of the economy or whether it's about being better prepared to deal with the impacts of a changing climate. And I think the decision makers that we need to be thinking about are not all the same. So we've got those that need to work at a national level. That will be government looking at the big picture. It will be looking at institutions, and they will obviously be thinking about the impacts for their sector. But crucially, there's a big sector that isn't really grasping this yet, which is the kind of financial community. And we really need to think about what of this information translates into something that community that really gets risk, actually, and is used to dealing with it, something that really helps them to make those decisions. But also at the local level. So the thing for me that brings climate change to life is the impact it has in real places and the impact it has on real people. And I think the challenges for decision makers there are different because they need to understand all the impacts, they need to understand how they come together, and they need to understand things that can have a cumulative or a domino effect, but also the things that feel like they're a bit confusing, the kind of too much, too little water. The fact that less people may die of cold in the winter, but more of the heat in the summer. So they have to make sense of that and translate that into something that is understandable. And obviously, that needs to be done with the political context. And the third thing I just wanted to touch on is we talk a lot about uncertainty when we talk about climate change. I think I personally would wish there was more uncertainty. It all feels alarmingly certain to me. So we heard last year that we had 12 years to get our finger out and make a difference. And now we have 11 years. So I just think we need to kind of keep a focus on not polishing the details so much as helping people to understand the detail, the impacts, and allowing them to help us shape what it is that we need to do in future. Thank you.
Okay, right. And sort of what I'll say reinforces what's just been said. I come from an area that's broadly within the area of risk communication and decision making. In fact, there's a Society for Risk Analysis, which is my main professional body, quite small internationally, but people work on this stuff in their day jobs and in universities. And I suppose the thing to say is risk communication is not just about communicating information, it's a whole bunch of other things. In particular, to come back to Liz and to Suraj's comments, it's very much about supporting decision makers, so trying to understand three things in a way. What is the decision? You've got to ask yourself that question. And that will differ. If you're the Mayor of London worrying about London flooding, the decision is very different from somebody in a health authority trying to work out whether their water will overheat in the future. Very different type of problem. You need to know who the stakeholders are, so there's a question of actually finding out who really matters in all of this, and these will be different for different circumstances. And then I guess for Jason and those of you from the science community, the natural science community, how might UK CP18 and the huge amount of information embedded in there help with this? Just a few things, just comments really about what does the field of decision and risk science suggest about all of this. As I say, it's not just about calculating and communicating uncertainty. First thing, you need to know the structure of the decision problem. If it exists, it may well be the actual problem you're trying to solve is unstructured. And so there's a question of how you kind of start thinking about that before you plug in any scientific information. You need to know what is at stake. I'll come back to that. Obviously, what the timescales involved. Important distinction between risk and uncertainty, which interacts with the structure issue, that some problems are more tractable in more probabilistic terms, others have much more fuzzy uncertainties attached to them, and then one needs to understand how that works. And then whose values are on the line, and when those values conflict in society, big social science question for us in our community, how do you actually deal with that? How do you engage the various stakeholders who may be disagreeing over what to do? The values issue, it's interesting. Some of them, Julia said early on, she's gone now, I would have asked, Well, we've got to get metrics, measurable stuff, you know, so we've got our, which is absolutely correct. You can't go places without measurable stuff. But some things are just not, that we might want to protect, are not actually very measurable. I'll give you a good example. A few years ago, there was, well, maybe 20 years ago, there was something called the Atlantis Project. It was an early EU project, and they posited what would happen to certain European countries under a 6-metre sea level rise, just as an experiment. So they went through all of this, and they came to the not surprising conclusion that the Netherlands had to be evacuated. And that then raised the question, well, what was at value here? Okay, so there were 17 million people. You'd have to move to Germany, France, some to East Anglia. There were a whole bunch of trillions of assets in euros that were going to go. But the real interesting question from the project was, what was the Netherlands now? In terms of its identity, in terms of not so much place, but what it really meant to actually move people out of a complete country. And that's at stake, and it would certainly be at stake for the Dutch population if it ever came to that. I'm hoping 6 metres is not on the cards. So think about the values that are at stake, and there's a whole host of things which are interesting in relation to this problem. And then the final thing I'll say from the risk communication and decision literature is, don't assume all the information you can provide people will be useful. Try and work out what is useful for people, and it may actually only be a small part of what you hold. So I'll give you a very simple example. I did work on chemical risk communication many years ago. We did work with people in small dry cleaning shops in East Anglia and in London, where they were handling chemicals, perchloroethylene, which is not very good for you in the long term. And two ways you can get exposure. You obviously breathe in the fumes, or dermal exposure. So if you take the clothes out of the machines early and they're wet, get it on your hands, and you get into the bloodstream dermal exposure. Now, everybody who was in these shops when we went to interview them knew that fumes were a problem, and that actually you had to keep the machines maintained to actually deal with this problem, or if there was a spillage, then evacuate and deal with it. So they were well aware of that part of the risk, but nobody really understood the dermal risk. So the operatives would all say, well, you know, we get it on our hands, and we wash it off, and that's fine. And according to the epidemiologists and medics, that was not fine. So the communication question then comes around, how do you get people working in this context to wear gloves or in other ways to take precautions against dermal exposure? So there's a sense in which identifying what they really need to know in the communication problem is a key part of this issue. So I'll leave that as a kind of thoughts to mull over in relation to everything we've seen this afternoon.
Jason, maybe that was a bit mean. Do you want to have a quick one word, maybe in response to any of that, before we open the field out of questions?
One word. I mean, what I've seen there, I find I agree with something that each of the speakers has said, but what they have in common is they've talked about the need to better understand the use of the climate information. It might be decision making, it might be raising awareness, but it's about understanding the diversity of different people and the different ways they use it. And I think we've had that in mind with UK CP18, but UK CP18 is just the first step in that. So it's encouraging to see the wealth of information that the panel has on the decision end of things.
Okay, thank you all very much. Now, opening the floor to questions. If you want to ask a question, please introduce yourself and give your affiliation, and wait for a roving mic, which I believe we have a couple of. Any questions from anybody?
Thanks. I'd be interested in your views about how much detail is appropriate. And I do know that different audiences need different detail, different users of information. But I just wonder if you've got any thoughts, about how much detail is useful.
Okay, anybody feel like they want to jump in?
Thanks for that, Mike. I think there is something about usability which might be more important than just how much because you want it there and you want it there in different layers, but you want to be able to aggregate it up, I think, to help you make the case to the person that you need to make the decision. So I think with previous iterations of the projections, we kind of got cleverer and cleverer at compiling stuff, but we didn't necessarily make it easier for people to use it. So kind of the more we knew, the more difficult it became to kind of make decisions based on it. So I do think we have to really watch that, which is why I think this user-centric approach is so vital, and look forward to a session where we actually look at some of the metrics from that. So who are the users, and what is the user experience, and what are the people actually making decisions finding with this, as opposed to the people that might be looking at it from just a kind of interest perspective. So is it really hitting the spot for the people that need to do something as a consequence?
I mean, a very quick comment to that. I mean, I think I'm not a specialist in it, but I think you can do what's called value of information analysis within decision analysis, which tells you roughly what the information you've got means. But you could do some sensitivity analysis, and if you're actually giving people more information, it doesn't actually change the way they're looking at the problem or the decision you're taking, then that tells you you've probably got a bit too much. That would be an obvious and rough rule of thumb to think through.
Just a very quick point. I think we have to be careful when we talk about detail. Again, we have to have in mind robustness. We have to be careful not to confuse things like high resolution with more information, and that's where coming back to understanding what you've got is also really important. So just a cautionary note of thinking very carefully what more detail means.
Yeah, excellent question. I think, as you alluded, context will dictate that, but there are now multiple decision analytic methods that enable, the identification of good decisions, good strategies under deep uncertainty. So, Baroness Brown talked about adaptation pathways, so that's one approach. Robust decision making, information gap decision theory. There's a catalogue, and these tools can be used when you have conditions of deep uncertainty, and I think so those can be very helpful when you have very little detail about what the future could look like.
Question up there.
So, yeah, you all talked about the need for, if you like, bespoke information, decision-relevant information. So one answer to that, and perhaps sort of looking forward at trends and so forth, is we just need a very large field of expert consultants who understand the climate information and understand business needs in lots of different sectors. So I guess that will grow and is already growing. But my question is, what do you think are some of the deeper knowledge gaps that won't be addressed by the development of that sector?
I mean, not from any position of detailed knowledge on the projections themselves, but I think the thing that I see people struggling with, and I know that we struggle with in the Environment Agency, is understanding the interdependencies. The question is, are we becoming more or less resilient as a society? And I guess the next few months might tell us that, about how many of our goods and services are outsourced, the supply chains are large and complex, and it becomes very difficult to then really understand what the impacts will be. And it might be that the unexpected weak point is the one that's going to catch us out. And particularly this becomes important when we look at what the things we all rely on, so the kind of ICT point, that actually every other sector is as kind of resilient as they are, but if we're all relying on the ICT to work and it doesn't, then that does absolutely become the weakest link.
Could I just say something about that? It's something that a colleague of mine, Brooke Fischoff, in the US at Carnegie Mellon, thought about 5 or 6, maybe 10 years ago, and wrote a paper on it, which was sort of a speculation, but at the end of the little exercise, we thought, actually, there's something kind of in the core of this here, that what's needed for good support for decision-making is probably not just consultants, because only one consultant probably won't be able to cover all the fields that are needed. So what we came up with was the idea of a boundary organisation that probably sat in the university, or a bit like Met Office, was very close to university activity, was independent, and it probably had some climate scientists and people who were doing the projection type stuff. It would have decision scientists who knew the decision tools and literature and adaptation questions around that. Probably then some social scientists who are doing work with stakeholders to try and work out the values. So if you posit, well, an organisation growing up, then I'd say, yeah, maybe that does it. But I suspect it won't grow up organically, and I'm pretty certain it doesn't exist. I've had certain claims since we wrote that paper that it did exist, but I still don't believe any of the candidates, who I won't mention, put themselves forward, fully do all of the things we thought were necessary. So I think there is there's a wider, and it's a very interdisciplinary type of activity, and people have to work together. We'll have to work on quite complex problems to, rifle through the detail of it in relation to what's required. So I think there's a bigger agenda there which doesn't yet exist. And when we wrote the paper, we knew nobody in their right mind would give us 10 million quid to do this. Burroughs tried in the States to get foundations to do it, and at Carnegie Mellon they do some of this very, very well. But nobody's ever really said, okay, let's really do this on the scale that's required for the challenge that we've got facing us. And that's the challenge actually for government and others the regulatory folks who really want support in some of the key decisions here are prepared to kind of back that kind of structure, which would bring all of these things together.
So certainly there's a role for consultants playing a really important part in the translation. Could they do all of it? My fear would be there will be some gaps. Some areas may not be well covered, but nevertheless may be really quite important on some timescale. I think there's the issue of looking at large-scale systems and where there is an impact that cuts across many different fields, affects many different businesses, affects many different regions, and those big systemic questions, I think, are more difficult to cover with the natural consultancy model, but there are examples where they've done that. I think one aspect that really concerns me would be thinking about co-development. So using UKCP involves to some extent learning about what it's good at, what it's not so good at. And it's really useful to provide the information on how it's being used back into the process of developing the next generation of projections, but more than that, developing the underpinning science programs like those we have at the Met Office. And so if we did go down a route that didn't have clear routes back into informing that underpinning science, I think you'd have a pipeline that would start to dry up on some of those new ideas, and that's really risky when it comes to the future development of the science program, in my view.
Yep. I think your question is very much fishing for, what are the fundamental research gaps that this community should be focusing on. I think there are many. I'm just going to maybe just give two examples of where I think we should be putting some effort. So one is around, and we've had a few questions around the robustness of climate projections, for example, from some of the audience members. So I think there's some sort of new impetus to look at sort of alternative ways of representing climate projections. So using storylines, using narratives, using tales. These are all different words that folk have used to describe qualitative descriptions of future climate, and as a way to treat the uncertainty as well. So I think that's a really rich, fertile ground that's being explored in regional climate, by your colleague Ted Shepherd, for example, and other colleagues as well in other areas. I think that was a climate science example. I mean, a more social science example is adaptation. I mean, we've had climate information in this country since 1992, the first UK CC. Anyway, so we've had 5 generations of climate scenarios. So users have been provided lots of climate information in the past. So there's obviously other barriers as well going on, and I think understanding what are the financial barriers, the institutional barriers, the psychological barriers that precludes adaptation decisions from being taken are important. Climate is just is one of those elements. There'll be all sorts of other things, people preparing for Brexit, for globalization, and so on and so forth. So climate is just one, and I think understanding that is really important. So those are 2 brief examples.
Thank you very much. Yes.
David Warrilow, President of the Royal Met Soc. Nick kind of touched on what I was going to ask about, actually, which is this whole question of the boundary organisations. Now, in 1997, DEFRA set up UK Climate Impacts Programme, which was actually designed to look much more at assessing the impacts and risks of climate change. And through time, it moved into adaptation. And the thing that it did was it was a clearinghouse between the scientific community and the users. So it was a way of ensuring that people could go somewhere and actually ask questions about how best to do adaptation, which is, let's face it, a really complex issue. Now, what we've got today is a very important part of the whole adaptation process, i.e. understanding how climate might change in the future. But if you were making decisions about adaptation, that's only part of your input, and there's a whole bunch of other things as well. The question I have is, do we have sufficient institutional capacity to do that job now in the UK? I mean, UK SIP is more or less come to an end. Maybe it's in a slight more sort of academic form now, but it's not forming the role that it used to do. So my question is, do we actually have a gap institutionally, which now needs to be looked at and filled, led possibly by government, but certainly I think it's a much bigger question than just one for the Met Office to deal with, or indeed individual sectors and individual companies, etc. Thank you.
So I think there are a number of gaps in the sense if we knew what they were, we could kind of plug them, and I think we're still working out in some cases what are the questions, let alone the answers. I mean, the Environment Agency took on, inherited, if you like, the really great record of UK SIP, and we built on their very best practice. And some of the approaches they had were just really simple and very effective. Things like an adaptation wizard tool for just having conversations about risk and understanding, where the ownership would sit for taking action. Excuse me. And when we were asked to take on that role for government, we were kind of, here's a few million and here's a few years. And I always thought, well, we'll see how far we can get. I don't think this is something we need to kind of be at forever, but we're not going to do it in one spending round. Being blunt, this predates Fiona, I should say. And I think we got so far, and the approach was always one of trying to build capacity in organisations to enable them to make better decisions that were robust, and to look at how you do this with professional bodies, how you do it with trade associations. And we took a kind of sectoral approach, which was the steer at the time. We've had lots of, and continue to have lots of discussions across the UK actually, and looking forward to the next European conference coming up in Lisbon actually, where we can kind of share best practice on approaches to this. And I think Scottish colleagues in particular were able to take more of a kind of geographical place-based approach, which I think is really interesting. So I'm still a firm believer we need to take actions once nationally to kind of just make sure you can't buy products that aren't climate-proofed. The public would expect it. It's the same with kind of energy certificates. But you've then got to bring this to life at a place level and understand those interdependencies. And the Environment Agency takes what it does really seriously, and we are kind of the lead body around flood risk and around water availability. But clearly heat is not our bag, and so there is, let's be honest, there's a gap of leadership there. Maybe we're getting to a place where actually, we worry less about boundaries, and it's more about whoever's in the best place to have the conversation, we get on and do it, because it's about collective action as well. Because, we could spend another 11 years trying to fix that and then find we've run out of time. So, I think we've got a lot to be proud of as in this country. We've got a lot that we know, but we absolutely need to kind of get on with we're taking that action. I think the system, more of a systems approach is really useful. But clearly, if we want to be providing stronger leadership on this, then we do, you're right, David, we do have to sort out the gaps that exist. But maybe we do that through conversations and through leadership, irrespective of where the actual accountability sits.
I'll just say, David, there is a gap, straightforward. UK SIP came close, I think, but it still didn't necessarily have everything you might want. We've been talking about the NERC Met Office Climate Resilience Programme, which is obviously kicking off, and lots of exciting projects will go forward over a period of time. In the longer term, and that's not a bid from me to lead something particularly at all, but in the longer term, one of the interesting objectives could be to think around that problem and say, what's the institutional gap? Well, actually, Suraj is a champion, so he should be jotting this down furiously. Have a think about that, and let's think about the governance arrangements we've got around this question, and is there something that could, not wanting to invent new quangos or whatever, that could be put in place which would meet some of those objectives, and I think that would be a useful task for the programme.
Yep, I mean, there's definitely a gap, I think, not just at the national level, but also at the regional level. So there were regional partnerships, and virtually all of them are gone. So, for example, we're trying to support the sort of Yorkshire, help desk for the UK climate projections through some NERC funding on impact, for example, regional impact. So, I think. I think it's a gap. I think, the UK Climate Resilience Programme can go some way to filling some of that gap, but it is a research-oriented endeavour that is trying to produce usable research for stakeholders that need to adapt to changing climate. So I think it can do a certain amount, but there's still a gap there.
Yeah, can I follow up on that? I mean, I wasn't saying the programme itself should do the research, but should do the research to work out if the organisation is needed. So, governance specialists, etc.
Next question.
Hi, it's Jeff Darch from Anglian Water. I've got a question and just asking the thoughts of the panel. Oh God, it's got very dark. I assume we'll carry on. Here we go. So my question is about bias and bias correction. So I think the UK CP18 products have done a good job about being quite open about where there is perhaps bias in the models and so on. But there's definitely a lot more emphasis on users doing bias correction than there was in previous sets of scenarios. And in many cases, I think that is appropriate because users can choose the metric on which they want to do the bias correction. Although I think it does, going back to the points about capacity, that might challenge quite a lot of users to come up with a way of doing that. And Fi's note, this supplementary note, is a useful start to that. So my question really is how there's clearly some better ways to do the bias correction from a scientific point of view in terms of the different strands. But what are the views of the panel about looking at bias correction in terms of sort of risk psychology, the capacity of people to be able to do that? And should we be working together as a sort of joint community to do that, or is it really just up to users?
I'll say something first from where we've got to on the physical side. So this time around, firstly, we're more open that biases exist within the model. They were always there, and I think actually this current generation of models reduces some of those biases. But how do you deal with that? So we had conversations very early on about not falling into what we felt was a trap of one size fits all on the bias correction. And I think that is the right thing at this stage in the process, that we recognise that what works for somebody will not be appropriate for somebody else. Not everyone can use a simple delta method. Quantile correction is not appropriate for everybody. I think the other side to this, though, is also
recognising that when you start correcting biases, you really have to understand the decision being made. So, as an example, supposing you correct a bias in temperature, you can then very easily end up with physically inconsistent set of precipitation if you start to correct that in either a similar or the same way. There are ways around that in some circumstances, but not always. So understanding if that makes a difference to your decision is really quite vital. And on some occasions, you may decide actually the bias in, say, one version of the model is likely to have such an impact on your decision that you perhaps don't use that model. And so it's bias awareness that I think we're trying to promote. Now the flip side of that, of course, is that it implies a very able user community. And I think we're going through that process. I know from discussions with Phi recently, whether we want to add some bias-corrected products. But I only really want us to do that if we can do it in a way that doesn't lure people into misusing the bias correction. And so I want to see the evidence that it's taking us into this more sort of decision-aware approach to using the data. Because I think that's a healthier place to be, but it might be quite painful to get there, I think, in some ways.
I can comment briefly. I think this links up a lot with the previous question, Jeff, in terms of capacity. Certainly, research we've done with local authorities, for example, have shown that there isn't capacity. I mean, austerity has had such an impact that there are no longer climate change officers, environmental officers, and so on. So, the ability to make sense of multiple strands or bias correction is very limited. And so this will vary. I mean, I think your sector, for example, water is better prepared and is able to sort of join resources to make sense of that. But I don't know if Nick wants to comment on the cognitive possibilities there. I think that actually probably needs some research to unpack that.
In a sense, I didn't want to comment because actually I used to do this stuff a long time ago. Again, within the subfield of sort of decision science, there is a whole area of looking at how experts deal with information and biases, and but that requires, I think, as Suraj just said, that requires study of what the experts are doing, quite close understanding of that in relation to the technical information. So again, there's probably a research program there. Is there actually psychological research on this? You might know better than I do.
For me, I'm more aware of the physical.
No, that's right.
There's a great deal of.
So I'm curious.
Nobody's. Well, there's a little, but there's
not much.
There isn't one that addresses the specific question of bias correction.
Yeah, so it's a good question. Yeah.
Thank you. Next question.
Yeah, David Stainforth from London School of Economics. I think this relates somewhat to Rowan's question in terms of where the deep knowledge gaps. Baroness Brown's slide had one of the slides that began with saying the input here is the UK CP18 information, and then all the rest of the information flowed from that. And there's been quite a lot of discussion about the need for multidisciplinarity, but the concept is still very much that the input is UK CP18. And that there is a separation there. There's a clear separation. This is the physical science community, in this case the Met Office, provides the projections. And then there's a lot of discussion about how they're used, what they're relevant for, what the uncertainties in them are, how they inform a particular decision. So I think I have a fairly simple question of whether actually the panel are comfortable with that. Because there is a very different scenario which kind of relates to Nick's point about the value of information, where you could say, well, actually, for these type of decisions, these are the variables, these are the uncertainties that really matter, and that can go all the way back to the models, to the physical understanding, and you can redesign your perturbed physics ensembles or whatever they are to explore that question if the value of information says that's a worthwhile thing to do. So much of the, I'm slightly concerned that much of the discussion maintains that as a separation. The physical sciences and then the action sciences are separated. And I'm just wondering whether, what your thoughts on, or whether that is the right way to go forward. Cigar.
Oh, thanks, Dave. I'll kickstart then. Yeah, I mean, I agree. I think it's about fitness for purpose, right? I mean, if you go back to Nick's description of a decision problem, there are many, many different decision problems in this context, and users will have to use different types of climate information to be able to solve some of those problems, and some of them will have to, will have to go outside UK CP18. And I think, I think James mentioned that, UK CP18 is not meant to be a one-stop shop. So people have to go and look beyond that if they're interested in the low probability, high risk outcomes, for example. Depends on their how risk averse they are. So I think it very much depends on the problem, and I think that will then dictate, where are you going to get that information, and so on. Yeah. But you want to respond, but
I do a little bit. I guess I would. So I completely agree with what you're saying. I guess maybe I'm looking forward to the future CCRAs. So maybe this is a question for DEFRA. Is it the right approach to be looking for one big product, or is there value in actually a diversity of approaches to the provision of climate projections at the national scale?
Yes, I mean, Julia isn't here, but I would suggest that her slide was drawn for this audience and the topic, and that whilst UK CP18 is a very important input, and it's one of the reasons why we wanted it to be in 2018, so that it could feed into the next climate change risk assessment, and whilst some of the projects are specifically about looking at the impacts of those projections, some of the projects that they've commissioned are not, and what we have tasked the ASC is actually to look at the totality of evidence and come up with a risk assessment. So I think it's not quite fair to say it's a single flow like that. The second thing to say is that the climate change risk assessment we have to do that every 5 years. The last one was actually done at a time when we'd already done one with the latest projections. So I've no idea when we will update the projections, but to be perfectly honest, I would be surprised if we weren't going into the fourth climate change risk assessment still using CP18. So there is a bit of a sort of decadal cycle imposed upon that 5-yearly cycle where the different climate change risk assessments actually kind of focus on slightly different things. And one of the things that I've asked the adaptation subcommittee to look at, this committee to look at this time, it picks up on what Liz was saying, and it's sort of this kind of integrated but differentiated. Is there a way of looking at a more place-based kind of way of assessing risks, a different way of trying to produce that assessment that makes it more useful for people to actually take action on? So I'd certainly refute the idea that we are in there's a set kind of way of doing these assessments every time. It's a dynamic process that I hope builds on whatever science is around at the time across all disciplines. If anyone's got anything
Yeah,
to
I
add
think
to that.
it's such a good question. So kind of what's going through my mind is, I certainly wouldn't start with the projections when I'm talking to people about climate impacts. Sorry, Jason, if that's a shock, but and I've been kind of looking at what is a helpful tool. It struck me when I did a session late last year how few of we talked about pictures and telling stories, but how few visual images there are that actually relate to people in this country and climate impacts. I've been using pictures of empty fields and empty reservoirs and thinking, oh, actually, I've lost the thing that speaks to values and how people feel about this. So, I think it's about how, at the end of the day, it's about how we use this stuff. And it's a bit like with the 1.5 degrees report. you know, I kind of looked at it and thought, actually, I can't quite equate what I'm being told about the report, what I'm reading in it, and what the newspaper headlines are picking up. And thank God the newspaper headlines had picked up and run with the story that no doubt no one would have ever said in a press release, because you can't say it like quite, you know, a bit too categoric. But, you know, what's the risk we're trying to assess here? Is it about the climate, or is it about the inertia of decision-making, put bluntly? You know, and again, it's not to be pleased about what we are doing, but we mustn't be complacent. And so I think all sorts of different approaches would be very relevant to how you bring the story to life, how we also show the risk of inactivity and not actually reducing the risk. But you come back to that question about how do you measure resilience? And, you know, we've all been grappling with this for a long time. And maybe we need to get better at measuring unresilience. You know, and actually, have we brought to life the pictures, the moving pictures of what 2030 is going to look like in this country? Because you read the 1.5 degree report and you read the difference between 1.5 and 2, and you think, I don't really want to be in the 1.5 degree world either. It doesn't sound particularly, you know, but you kind of like, no, these are really important messages. Well, but are they? Is it just another layer of information that allows people to hide behind the difficulty of the science and then kind of go, I'm so overwhelmed, I'm just going to carry on because I don't really know anymore what the right thing is to do?
I'd like to give James the opportunity to respond because I know he's really eager, so I'm going to sacrifice my turn on this time to allow James to
As long as he responds and not ask a question, because he's not the next person for asking a question.
No, it's a response.
Okay.
Well, I was just going to follow up a little bit on this conversation between David and Siraj. So I worked on the second CCRA, and certainly my perception was in the first CCRA, there did seem to be this perception that it was the UK CP09 scenarios and pretty much nothing else. And, you know, and I was actually quite encouraged that when we came to the second CCRA, there was more consideration of other sources of scientific knowledge, idealized studies, you know, H++ scenarios, that sort of thing. And I think that community was starting to learn how to do, I think, the sort of thing, some of the sort of thing that you're talking about. And I would certainly hope that the CCRA3 would pick that up and develop it more. I mean, obviously, as a developer of UK CP18, I'd always hoped that it was an important source of input, but I would never want to think of it as the only or the kind of, you know, always necessarily dominant source of input. So I hope that community working on the CCRA can continue to learn how to bring in some of this wider information, like scenarios of idealized ocean circulation collapse and things like this, and actually turn them into the advice that then informs, you know, the decision areas for adaptation and risk priorities, for example.
Thank you. I think we've only got time for one more.
Can I just very quickly react? Maybe one more, two quick comments, maybe to Dave and Liz. I mean, I have a lot of sympathy for what you've said, because I think, you know, based on our social science research, I guess what happens in practice is that UKCP, for example, based on UK CP09 history, it becomes a de facto, it is the national climate scenario and projection. And while the CCRA may have been different, if you look at the adaptation reporting powers, I mean, every single report there will have used UK CP09. So, I mean, if that message that this is not a one-stop shop needs to be very well communicated to the community of users, so that they recognize that, look, this is not everything, we haven't sampled all the uncertainty, we don't know everything, this needs to be very well communicated. Just on sort of, I guess, visions of the future a little bit, I think the other thing that I think you're talking about is we are reducing everything to climate in this meeting. It is about climate services, and I think it's useful to recognize, so I'm aware that there's going to be, for example, after 20 years, we're actually going to have socioeconomic scenarios as well. So the Center for Ecology and Hydrology in its national capability program is producing some socioeconomic scenarios that will have a bit of a flavor of, you know, well, what will they have 5 different socioeconomic pathways, so they've essentially downscaled that from the IPCC, and that provides some stories about, you know, well, what could the UK look like socioeconomically, and combined with climate, they could produce some very vivid images, stories that could be eventually communicated to public and other stakeholders as well.
Nick, did you want to say something? Can I-
Well, only briefly.
I'm not going to get one more question.
Just very briefly, yes. No, I agree with your comment. And again, that was the idea of having an organisation that had many of these things together. The problem comes in, and then there's a back and forth that goes on, which helps the scientists try and find the information that might be critical. And also, language is often difficult and not right here. We talk about risk communication, and that's what I'm doing. Now I'm telling you something, but actually communication is always two-way, and so the risk communication literature has said for almost 30 years now, you have to think about it as a two-way. It's always a two-way thing. You're always trying to find out what your users want in order to inform your science, and the users want to find out what the science is about in order to inform their decisions, and all the way through the process. So I think that's the way to think about it.
Thank you. Last question.
Okay. I'll try and be quick. I'm Richard Harding. I'm actually from the Centre of Ecology and Hydrology, but this is a question really from civic society. I live in Oxfordshire. We're putting together, or Oxfordshire County Council are putting together a growth plan up until 2050, which is out for draft consultation at the moment. It makes mention of climate change in the introduction and then does absolutely nothing in terms of adaptation or mitigation. And I guess it's just too hard. And I think this I hear echoes of the solution or a strategy in some of the things you've been saying, but we need to somehow make our decision makers, particularly in the local authorities, who, as I think you said, are very strapped for time and money these days, to try and encourage them to put things like environmental change and climate change right at the centre. And I suppose my question is how do we get things like UKIPS 18 actually right at the centre of decision planning rather than as a sort of afterthought?
Challenge.
In 1 minute.
I mean, I absolutely agree with you. I recently went down to Hampshire to talk to the commission that they set up about how they set their vision for 2050, and it was all about, again, not telling them what the answers are, because we don't. It's about enabling people to make robust decisions that are putting sustainable economic growth at the heart of what they're doing for their people and for their community and environment. So I think some of the more forward-looking authorities are thinking like that.
Any last-minute thoughts?
Yeah, so I think part of it is recognising that not everybody is at the same stage. So part of it is the awareness raising. But I think at the other end of the scale, we also need to make sure products like UKCP18 and other ways of using models feed into guidance and national standards more frequently, and that update becomes almost a matter of course when the science moves on. So you come at the problem from both angles. You're raising awareness at one end, but you're trying to build the most recent science in another way that allows people to benefit from the findings, but without necessarily everyone having to engage directly with the scenarios.
Last thoughts?
Well,
I was going to say not to.
No, just, I mean, we have huge lack of capacity on the ground to deal with these things, either within, also Scotland are doing good things, but either within the devolved administrations, the regions, the local government, and that's not a problem we can fix here. It's a resources problem, which we know that the levers for that are elsewhere.
Okay, I'm really sorry for those who still have questions. You might be able to catch some of the panel members afterwards at the reception, but I'm being glared at by Brian to bring this session to a close. Thanks particularly to the 4 panel members for being so interesting that everyone's got lots of questions, and thanks to everyone who asked questions as well.
So I'm sorry to, is that on? Yeah. Okay. I'm sorry to Sorry to curtail the discussion there, which was so interesting, but we also have a last session with 3 interesting speakers. And this last session then is, what does UK CP18 mean to the practitioner and academic community? And so there's 3 speakers here. And we have Dr. Ella Howes, Dr. Mike Moorcroft, and Jeff Darch, Dr. Jeff Darch. Let me introduce Ella first. Oh, which order are you speaking?
I think I was first on my list.
Okay.
I'm very happy to give way.
Okay. No, Jeff, you're here.
No, I'm Mike.
Mike, sorry, Mike, you're here, so let me introduce you, except I've left a bit of paper behind. So that's things. Right. Right, so yes, Mike, you're here. So we have Mike Moorcroft from Natural England, and he's talking about using climate projections to support nature conservation and environmental management. And Mike is an ecologist at the Government Conservation Natural England, where he leads on climate change adaptation and mitigation. And I think, given the time, I'll just leave it at that and let you go from there. Okay?
Yes.
So you have 10 minutes, and we'll have 5 minutes at the end for the questions on all 3.
Excellent. Right, thank you. Okay, without further ado then. Yes. So nature conservation and wider environmental management. Why should we be interested in climate? Well, put bluntly, the natural environment and the species, the habitats, the benefits that they provide to people are all fundamentally sensitive to climate. We can see already species moving northwards, spring events, things coming into leaf or birds laying their eggs happening earlier, changes in communities, and a variety of interactions with other pressures. We can see that our environment is sensitive to climate. Now that presents a challenge to an organisation like Natural England. We're the government conservation agency, so we're part of the DEFRA group of organisations, and our remit stretches from developing the science base in order to to advise DEFRA for a start, but also to advise the wider practitioner community, right through into actually much more hands-on work. So I have colleagues who work with farmers, I have colleagues who run nature reserves, people involved in designating protected sites and managing coasts and so on. So this is an area where we really need to be able to span that gulf really between the academic world on the one hand and the really practical, literally down in the dirt end of things at the other. So how do we approach adaptation? And I'll come on to where projections fit in towards the end of the presentation. So you'll have to be patient for that bit. But it's important, I think, to get a sense of what we're about. So some of the changes we need to deal with are just inevitable and we have to manage them. That's my top left bubble here. But there are other things where we can build resilience of the natural environment, and then there's other things where we can engage in what we might term ecosystem-based adaptation. I'll explain each of these in a little bit more detail, but they're all underpinned by a good understanding of evidence, of which projections are one very key part. So building resilience, some of that's about restoring ecological processes in this degraded environment that's true of much of Britain. So for example, on the right-hand side, restoring a peat bog to a healthy hydrological state. That will give it a degree of resilience to changes in climate and the extreme events that may come with it. Reducing fragmentation of our landscapes, a little patchwork situation that we have, which can look quite attractive, like on the left-hand side. But if you're a species trying to move around, find a space where you can continue to exist, it's a challenge. So there's things we can do to build resilience. But we're also increasingly having to face up to inevitable change. So this isn't necessarily all bad. This is a silver-spotted skipper, a little butterfly, which was really just hanging on in Britain, right down on the south coast and South Downs. If you look at the series of maps on the right-hand side, at the top you can see 1982. The little red spots are where that silver-spotted skipper existed, where it had been recorded, and then you can go through 2000, 2009, and you can see it's spread through the landscape, and it's gone further as well. I know, because we had somebody out there last summer looking at it. The reason for that is almost certainly that it's a species that is only just climatically suitable for the UK at the moment. But as things have warmed up, it can do much better, so it can spread. That's a good news story, and we need to be able to accommodate that change, so to protect species where they're found now, rather than where they might have been in the past. But it could equally have been an invasive species, a damaging species that might spread through and cause damage, or it might be a species hanging on just at the southern tip of its range, which might be at threat. Well, the next element of what adaptation looks like for a conservation agency is about how we can actually manage the land better to help people adapt to climate change, or ecosystem-based adaptation, as it's sometimes called. So, at the most simple level, if you have cool green spaces within cities, like, for example, Hyde Park, on the right there, just down the road, you can have a measurable cooling effect on your city, making it more livable in a heat wave. If on the coast you create more intertidal habitat, and this is an example of Wallasey Island, where the coastline's been realigned to allow for rising sea levels, to allow for change, and it's just the early days there, and it will in time produce salt marshes and mud flats, good for nature, but also provides a degree of natural protection against storm surges and extreme events. So if we manage the environment better, we can help people to adapt. So it's a win-win. But where do projections come into this then? Well, I'll start with, I suppose, the obvious comfort space for people who do modelling and familiar with climate models. So this is one tangible example from UK CP09, where it was possible to model the distribution where species were found for a wide range of different species, hundreds of species, in fact. This is the willow tit here, and the kind of bright map in the middle shows you where conditions are currently suitable. That's the green and the yellows, and the red is where it's not suitable. And then you can project forward, you can drive that distribution with inputs from a spatially coherent set of projections and look at where it might be suitable at a given point in future, obviously with assumptions about what scenarios you're using and so on. So it is possible to do a rather similar thing to what we do with projections of climate. We can project where species might be, subject to all the usual caveats and more, but it's an interesting exploration of a range of possibilities. However, I have to say, if I'm really honest, and this comes back to some of the questions earlier, we don't do much like that. Much more often, we're interested in quite a high-level sense of how climate is likely to change, the range of possible futures. So, when we come to review the management plans for our national nature reserves, done every 5 years, one of our greatest achievements as climate change specialists within the organisation, which I'm rather proud of, is to get a line in there saying you must assess the climate change vulnerability of your management plan. And starting point for that is to ask site managers, and if necessary to work with them, to look at projected future changes in climate on the basis of projections. It was CP09, we're now moving into using UK CP18. Now, how you set that up is really important. They don't have time to study all the possible different probability distributions and so on. We need to give them a set of plausible futures. Say, this is the sort of thing you might see happening. If this were to happen, then what might happen? What might be your assessment of impacts? And it's often dealing at a very descriptive, subjective level, but it's useful to have something concrete and specific to work on in order to move through into a vulnerability assessment and derive responses. This is not really a modelling approach. It's taking basic information and using it in a descriptive evidence, expert-led way. When I say expert-led, the people who manage the site are really the experts, with people like me coming in if necessary. Which projections are most useful? Temperature and rainfall, probably the key things for most things ecological. But sea level rise is absolutely critical in a coastal, in an island country like ours. And also the possibility of extreme events and what we can understand around drought. Understanding, of course, there's lots of complexity around that, but those are the sort of issues. So I reckon I've got 50 seconds left. Let me run through my conclusions. So adaptation is essential for conservation and land management, and climate change projections often form a starting point for adaptation. They can be used in a quantitative way to drive models of impact, but much more often we're using projections qualitatively to give an idea of a range of possible futures. Something I haven't really gone into, but is absolutely key to my life, is that uncertainty in ecological impacts is considerable. Much more, in fact, than a lot of the climate system. So we need to take account then of that uncertainty and look at things like direction of travel and the range of possible impacts, direct and also indirect. So the knock-on effects of a change in one aspect of the environment on others is equally important very often. And I think that's my time gone, so I shall stop.
Thank you very much. You want to just take a seat down there. Okay, so we've Jeff. Fine. So next we have Dr. Jeff Dart from Anglian Water. What does UK CP18 mean for the water industry? And so Jeff is a water resources strategy manager at Anglia Water, and he's responsible for the development of long-term plans that balance water supply, demand and risk. So over to you, Jeff.
Thank you, Brian. Hello, everyone, and thanks for being here still at this late hour. So 10 minutes, a bit of a whiz through. I won't cover all the detail on the slides, but I hope the slides can be circulated afterwards so you can catch up. So I'm going to talk a little bit about climate vulnerabilities and the way that Mike did, how we factor those into something that we call the Water Resource Management Plan, and I am going to focus on water resources as the exemplar for the activities that we do. How we use UK CP09. Been mentioned a few times, but actually the additional analysis that we did to partly to fill gaps, but to do some other analysis that didn't rely purely on CP09. The adaptation that we've ended up with in our current business plan and water resource management plan. A look at alternative approaches to decision making that we're now using, and the potential use of CP18 before some emerging challenges. So hang on to your hats. So these, I come from East Anglia, so it's a vulnerable region from a climatic point of view. It's classified as water stressed. It's pretty dry, low-lying, sensitive habitats. We've got soils that react interestingly to the weather. It's also an area of massive growth. We're predicting about 20% more people living in our region in 25 years' time, two of the UK's fastest growing cities. We also have a lot of infrastructure in the ground and in some cases above the ground that we have to look after. And we also have a very variable demand situation. So demand typically around 1.1 billion litres a day we're putting out, but that can increase by up to 30% on a warm day. So we're vulnerable, and these vulnerabilities are not unique to us, but perhaps slightly more acute being in the east. So we have to prepare something called a water resource management plan. It has to set out the supplies that we have and the demands that we think we're going to have on our system every year for the next minimum of 25 years, and we typically go beyond that. So scenarios of the future are a natural input to our planning process. And we have to update these plans every 5 years, and we're just going through the finalization of our current plan. We use UK CP09 in a whole bunch of ways, and I'd be quite happy to do an hour or two on that. But the most extensive use really was made of the spatially coherent projections, and that is because as a water company, we need to look at how climate change will change over space, but also the coincidence of variables. PT, so potential rapid transpiration, and rainfall being the two primary variables that we're interested in. So the bottom plot here, for example, is 3 time slices, top to bottom, 3 emission scenarios, the 11 members of the PPE ensemble that were in the spatially coherent projections, and these are the changes from base for different, what we call flow percentiles, so Q95. In the bottom of each of those rows is the very lowest flows. And essentially you can see a lot of red in there, which means a lot of agreement about flow reductions, but not ubiquitous across those 11. We've also made some use of the probabilistic projections and the high plus plus, particularly for comparison with the SEPs, which we've majored on. And that top right plot gives a comparison of some of the stochastic data that we've used compared to the high plus plus and looked at how they relate to each other. Elsewhere in the business, we've used products focusing on high-intensity rainfall, more of which in a minute, and obviously sea level rise, given our sort of geographic location. But as I say, we've also done a whole bunch of additional analysis, working with the Met Office and with UEA in particular. We've done some work using weather generators to look at alternative sequences of historical climate, factoring in additional pressure indices other than the NAO. We've looked at and reviewed the meteorological drivers in 7 key droughts over the past 100 years. And we've also done extreme value analysis using Bayesian methods with the Met Office. And a couple of these publications are now on the Climatic Research Unit website. So kind of going into the future, this is a big deal for us. Again, you can look at our water resource management plan online, but essentially we have some pretty major early reductions in what we call our supply-demand balance going forwards, and the impacts are sort of labelled in the coloured boxes at the top. So climate change, we're going to lose around 55 million litres a day, taking into account the impacts of climate change over the next 25 years. Moving to being resilient to a 1 in 200 year drought is 26 megalitres a day over the same time period. And we're also reducing our abstraction in certain areas, which is another big impact. So over the next 5 years, we're going to move from a position of surplus to a position of deficit, at least in planning terms. And that's driven a lot of activity over the last few years in terms of where we go next. And climate change, obviously, is an ongoing risk. I should say just quickly, part of the reason why we have a very large climate change impact in the next 5 years is essentially that we're catching up, if you like, in methodological terms with the climate change that we've seen since the 1970s. And that's a shift that the industry is making over the next few years. So what are we doing? I don't have time to sort of go into this. We're doing measures both on the demand side, so leakage reduction, trying to encourage customers to use less water. Smart meters are going to be rolled out across our region on the demand side. On the supply side, we're connecting areas that have surplus of water to areas that have less water. But one thing to take away from this is that we're making a very major investment, probably around £300 million, specifically in climate change adaptation over the next 5 years. So we're moving to adapt and not just sort of building capacity in terms of understanding risks. I mentioned alternative approaches earlier, and this has been raised a few times today. We do a lot of work in terms of understanding our system sensitivity. We have system models from catchment up to sort of regional level. We've also done a lot of work, particularly through a regional group called Water Resource East, on robust decision making. So using techniques that are trying to evaluate robustness of a whole number of alternative solutions to a really wide range of future scenarios. So, for example, we've used 291-year stochastic weather sequences, alternatives to the last 100 years, along with 33 climate change scenarios and 3 time slice variations of those. So an awful lot of data, a similar number of, we've also looked at other scenarios on the socioeconomic side as well. And we can use those to sort of look at trade-offs between different option portfolios, a very different way of doing planning. 2 slides to finish with. Potential use of UK CP18. So this is reasonably new. We're not going to factor CP18 into the current version of the business plan and the water resource management plan, but we absolutely will, along with other information for the next set of plans. I think our current feeling, and there are projects going on with the industry to validate some of this, is that we will make most use probably of the global model projections and the regional model projections, where again we have the benefits of spatial coherence. Also interested in exploring the weather types, which ties back to the work we've been doing with UEA, and obviously the resolution. There are some issues there around the uncertainty, so we'll be using that and comparing that with the probabilistic projections along with the observations. And we will carry on using things like the marine projections to look at flood risk assessments along the coast, and there's some major advantages in the updates to that. So emerging challenges, so this is sort of my last slide, throwing this back to perhaps the next set of projections, but also what we can do in terms of an impact sense. So what does climate change mean for recharge? Well, we can model this, but actually there's a difference between the sort of modeling and reality, and are the models that we've calibrated on the past actually fit for the future? Do we need to sort of re-examine the physical processes that are going on there? What does climate change mean for water quality? We have some clues to that, but certainly not enough information. And we often tend to talk about drought and climate change as if they're 2 different things. And we need to do a lot more work over the next sort of 5 years, probably 3 years really, to integrate that. And we've got a couple of new PhDs kicking off, one at UEA, exploring climate model output, one with Ted Redding, looking at storyline approaches to try and take that forward. And finally, adaptive planning. Can climate change be a signal within an adaptive kind of process, or must adaptation be fully proactive? Can we wait? I don't think we can, but I'll leave that out there. So apologies for a slight whistle stop, but there you go.
Thank you very much, Jeff, and thanks for that rapid tour through that. And as you said, the slides will be available, so if you want to spend more time on it. So lastly, we have Dr. Ella Howes. Coming on at 5 to 6 is really a good timing for you. So she's going to give a review of the range of UK CP18 marine projections. And Ella's a Marine Climate Change Project Officer at CFAS, the Centre for Environment, Fisheries and Aquaculture Sciences. So her background was researching the effects of ocean acidification on Mediterranean zooplankton, and she's going to tell us all about that. No. Over to you, Ella.
Thank you. Oh, I'm very loud. So I'm going to give you kind of a similarly whistle-stop tour of ways in which UK CP18 marine projections might be used. I'm aware that sometimes the marine uses can be a bit mysterious to the more terrestrial-based people. So this is just going to be a really quick look at the variety of work done in CFAS and how it might be useful. I should also caveat this by saying not all of these are projects I work on. So if you have any burning technical questions, I might have to go away and find out from somebody else. So just a quick slide to remind you what is in the marine projections. And as Matt said earlier, there's a range of projections up to the end of the century, sea level rise under a variety of emission scenarios, storm surge, changes in tide and wave climate, and then also the projections to 2300. And as part of the development of UK CP18, you may have seen the poster outside, there was the demonstration project delivered by WSP. And this really looked at how the projections on sea level rise and surge can be used to inform shoreline management plans. So the management of the coast and how it changes the responsibility of that falls under the Environment Agency and local councils, and they use a non-statutory plan, shoreline management plans, to look at how the coast will change in different areas under different timescales, sometimes more than 100 years into the future. And what WSP did was use the data from UK CP18 to make these shoreline profiles to give a better idea of how that would change over time, which helps to inform planning decisions, where is a good place to have a coastal development, where not, and where should be prioritised for resources to continue to protect in future. So as you can imagine, a highly emotive topic that affects a lot of people, so having the right data is very important. And so something completely different, this is touching on the communications aspect that we've heard a bit about during the panel discussions. One of the projects that I work on is the Marine Climate Change Impacts Partnership, and the aim of this project is to provide a coordinating framework for the UK to communicate marine climate change science to policymakers and managers in a way that's useful and timely and understandable. The way that we do this is with the report cards that are up there. We have two flavours of report card. We've got a full report card, which covers about 30 topics under the climate of the marine environment, so looking at the physical and chemical changes, how those changes will then impact on biodiversity, and then what effects we expect to see on economy and society. We also do special topic issues, looking, for example, at how climate change in the marine environment might affect the marine leisure industry or fisheries and aquaculture. And the way that we produce these cards is not to actually author them ourselves. We have in-kind contributions. We approach experts, academics, managers from the government agencies to author on a particular topic. And this is everything from sea level rise all the way through to cultural heritage. And this is actually where we've already been using the UK CP18 outputs. Some of our authors, we were lucky enough to have authors that have worked on UK CP18, so those results are already being incorporated into the backing papers, and we are now in the process of extracting the key messages to produce these report cards, and they feed into the National Adaptation Planning and also the Climate Change Risk Assessment. Another area of our work, we are involved in marine planning. So as part of the Marine and Coastal Access Act, all areas of inshore and offshore UK waters need to have a marine plan in place by 2100. And a key part of this process of developing these marine plans is looking at the evidence base. Obviously, it's vital to know how your coastlines will change, which areas are at risk from storm surge and from waves, in order to sort of decide where you're going to put your marine activities, your coastal developments, how you're going to designate areas for marine protection. And there has a huge impact on the policies that will then be in place, because these plans will be statutory, and there are some in place already and are statutory. So it's very much going to form the basis of how we manage our marine environment going forwards. We have a lot of coastal process work at CFAS, and as you know, the UK has a strong maritime and shipping history, and as container ships get bigger and bigger, so do the channels that they go down need to, and that involves a huge amount of dredging. So we end up with this enormous amount of dredge spoil taken from these channels. And once you've assessed that it's not hazardous or containing heavy metals in any way, then the European framework really promotes reuse, and especially beneficial use. And the photo here actually shows one example of beneficial use, and that's Lodders Cut Island. It's creating bird habitat in the middle of the river, and it's now starting to be colonized by salt marsh plants. And obviously, knowing that you've got these projects in the right area is very important. I can just show you another Another example of that, this is Allfleets Marsh, Managed Realignment Site, and this kind of links a bit into Mike's talk. This is an area that would have only built up as mudflat, and the use of this dredge material has encouraged the growth of salt marsh. And again, when we're modelling and looking at where we're going to put these sites, obviously you don't want them to be washed away in 2 years' time. So the sea level rise projections, particularly the long-term ones, as well as the storms and surge projections, are very, very useful. We also work a lot on nationally important infrastructure projects, for example, nuclear builds. The BEAMS project is the British Energy Estuary and Marine Services project. And here you can see the outputs of some modelling for Sizewell C, a proposed nuclear development. The graph on the bottom, what's that, left for you guys, you can see that you've got bidirectional waves. And the other graph shows that they're coming mainly from the northeast and the southeast. And this is a model output from a model called TOMOAC, and from here we feed in the different scenarios of sea level rise, the different scenarios of waves and storm tracks. And this is essential to know what the likelihood is, where this development needs to be protected, and how it can be future-proofed, in fact. And just to give you something to finish on that is completely, well, not completely different, similar but different. We also work overseas, and one of the programs that we're involved in is the Commonwealth Marine Economies Programme. Some of our work is taking place in the Caribbean, and these are images from Grenada showing the damage after hurricanes Ivan and Lenny. These are two of the strongest hurricanes that have hit this island, and they've caused huge disruption, huge economic cost, loss of life, and it's something that we're looking at because, as obviously under climate change, the conditions for hurricane formation become more frequent, and it's likely that they're going to be impacted more. So we're also using the same model that was used in the previous example, which is the Telemac-Tomoac model. And this is a collaborative piece of work, working with some people from National Oceanographic Centre in Southampton that were also involved in UK CP18 development. And it's really using, it's layering up GIS outputs and the outputs from these storms and wave models to model these three events. And we were looking at Ivan, Lenny, and also a 100-year return period. Just to really highlight which areas are likely to be more vulnerable in future under different climate change scenarios. And this is really somewhere where this wider global sea level rise work that's been undertaken in UK CP18 is going to be really useful. So with that, very, very quick whistle-stop tour, I'm going to wrap up. But yeah, like I said, if there are any questions, I'll do my best to answer them, and well done for being so alert at this time.
Thank you. Thank you, Ella. And we now have 5 minutes on the programme. I assure you I'm not going to give a 10-minute overview at the end of what's happened. I think that would test everyone, including me. So let's just have a few minutes then for questions of these three speakers. Late in the day, but really good quality material presented here. Yes.
Now that we have Anglia Water here, can I just resurrect the question I asked, is how water companies can sensibly deal with not just the analysis, but if it's correct, we're going to have warmer, wetter winters, hotter, drier summers, and the summer rains are going to come in large lumps and not spread. What sort of things can be done to make better conservation of the water as and when it comes, when it may not be wanted at the time?
Thank you.
Yep, sure. There's a whole bunch of things that can be done both on the demand and the supply side. So on the demand side, obviously, we'll try and reduce people's consumption, including peak consumption, but also reduce wastage from leakage. So that, that's important on the demand side. On the supply side, we would look at, and we are looking at a variety of options. They do include new reservoirs, but also desalination, water reuse, and interregional transfers. Obviously, you can look at the increase in winter rainfall as a potential advantage with climate change, but if our reservoirs are full, which they do tend to get to at the end of winter, then essentially that water goes past the abstraction point. So more storage obviously is a way to deal directly with that problem, but I would say it's just one option that we're considering amongst other options.
So there's a question each for Mike and Ella. I'd like so is anyone going to the Habitat and Natural England and how they're going to make look after all these new species that want to come, the old species that are finding it difficult? Yes.
Thanks. Well, a sort of combined question.
Yeah, that'd be good.
Ecosystem services and natural capital. To what extent can some of these projections be used for ecosystem or green infrastructure approaches to flood risk, for example? Can it assist that approach, which is generally quite difficult to sort of link in a multidisciplinary way and get off the ground?
I think it can help, certainly. I mean, you're right. It has historically been the case that things like natural flood risk management have been much harder to quantify benefits in the same way that you might do for more of an engineering approach. But the evidence base is growing fast on that. In terms of modelling different, projected climate change scenarios through that feels to me still like quite a big step at the moment. But in terms of contextual information for why it's perhaps even more important, it's certainly valuable. And in terms of, I'd like to think we will be moving in that direction, but certainly the evidence base has strengthened no end, and there's a lot of pilot studies going on. And I think compared to 5 years ago, it's a very much more optimistic view I have now that people are starting to get that message and explore the opportunities. I don't know if Ella, if you want to say something about coastal.
Yeah, I think there's also opportunities, I think, overseas. Maybe you were alluding to UK, but certainly within the CME programme, the Commonwealth Marine Economies programme, we're working with a lot of small island developing states, and this information is very useful to make an argument, particularly for natural protection of the coast. Coral reef, mangroves, seagrasses are all there, and there's multiple other benefits from them, and certainly these projections and the type of modelling that you saw for Grenada are actually really useful to work with those projects and maybe complement some of the blue carbon projects that are going ahead in those places.
Right. I think given the time of day, I'm going to have to draw proceedings to an end, and I'd like to do that. I think the speakers have given us a really good tour around this area of role for climate services in dealing with the risk and the risk that's increasing, and particularly the contributions of UK CP18. So I'd like you to give them a round of applause. And thank you very much, all of you. There is a reception outside, and the posters are still there.